Hey guys, welcome back to a new complete game tutorial video in Unreal Engine. And in this video, we are gonna make an endless runner game where the whole environment will be procedurally generated while our player keeps running forward. You are gonna learn a lot of things from this complete game tutorial video, since in this video we are gonna work on many different systems and make them work together to build this amazing game, like smooth character movements, spawning obstacle platforms and environments, not just completely random but pattern wise to give the game a better look, and many other systems along with touch input system so you can swipe your finger around to control the character movements in case you want to build this game for mobile devices. And this video is a complete compilation of the Endless Runner Game series playlist that I was uploading for last 15 days. So you can also visit that playlist if you want to continue watching in parts. And you can also download this whole project from my Patreon. So you can just grab the project and can use it to quickly build your game and publish it wherever you want. And it took me more than a month to make these tutorial videos for you guys. So if you can, then please try to support me through the Patreon. So you'll get all the benefits along with me being able to publish more such videos in the future. So I think it's already a quite long intro for the video. You can get all the links in the description along with my Discord server. Alright, now let's jump into the video. So for that you can use any of the Unreal Engine 5 versions you have. Like I'm gonna go with 5.6. So let's launch the engine. Alright, so here we are gonna start with a third-person template since it comes with a lot of stuff we can use. And from here you can select your project location. Now for this project we are gonna make logic with blueprints. The target platform will be desktop as of now and set the quality preset to maximum, and we don't really need a variant for this project. So now let's just give name to this project. I'm gonna call this Endless Runner. Now first of all I'm just gonna go in the project settings and turn off the lumen since it's really heavy on my computer. And also in the editor preference I'm gonna set the window default open location to main window. Now it's better, I guess. Alright, so now if you hit this play button, here you'll see we have this default player which we can move around and play with, which feels pretty nice already. And to make an endless runner game out of this, we can use some asset packs from marketplace so that we don't have to design 3D models by our own. You can even do that if you want to, but I think most of you are just beginners, so you can use some free asset packs. Those are available in the marketplace already. So let's open up your Epic Game Launcher and here you'll see this Fab Marketplace. So here let's search for the road and extra buildings. Here it is. This is a free asset pack that contains different kinds of roads and other assets that we can use for our endless runner game. So let's add to the project, and here if you don't see your endless runner project, click on this show all project. Here it is, but this isn't compatible for 5.6. So from here we can select closest Unreal version that we have installed and this asset pack is compatible with. In my case I have 5.5, so let's select this and click OK. Now the asset pack must be inside your project. So let's go back to your project, and in your content browser, here you'll see this low poly city folder. If you go inside this and select mesh folder, you'll see all these 3D models, those which came with this asset pack, like different kind of roads and buildings. Now as of now, I'm gonna use this SM Combine 54 static mesh to make a placeholder road out of it. So let's copy it. And let's go out, and here let's create a new folder. Let's name this assets, and this is where we are gonna keep all our assets that we are going to use in this project. Inside this, let's make one more folder, name this floor, and here I'm gonna paste it. Let me call this road 1 SM. Now if I place it into the level, here you'll see this is a plain static mesh with a gray material, and you can scale this to make it look like a road. But more of that later on. First, we either have to delete all these blocks and meshes that are in this level, or you can create a new level. I'm just going to delete all these blocks from the level since we don't need them. So in your world outliner, here you can see there's a folder called playground which contains all these blocks inside it. So just select all the actors inside this folder and delete them. There you go. And now we are going to place this road mesh, and let's keep it at the center of the world. Means set all the location axes to 0. So this is the center of the world, and this is from where we are going to start building our road. But first we need to edit this pivot and shift it at the starting point of this mesh. This is because we are going to spawn multiple roads at runtime, and these mesh can have overlapping issues if they don't have a correct pivot point. So to edit the pivot, let's switch to modeling mode, and here in the X form, click on edit pivot. Now you can shift this pivot wherever you want. I'm gonna keep it just at the edge. And when you're done, click on accept. And now whenever you will place this asset in the world, the pivot point remains the same. Alright, so now let's create a new folder. Let's name this blueprints. And this is where we are going to keep most of our blueprint classes. Now inside this, let's create one more folder, name this floor, and here let's right click and let's create a blueprint class. It is going to be an actor. Let's name this floor BP and open it up. So here you go, this is the viewport and this is the event graph where we are going to write all the logics related to our floor blueprint. And here in the components, we don't have anything here yet. So first we are going to add a static mesh. Let's call this floor mesh. Now from here, let's select the road 1 SM which we created before. Here you go. And we are going to scale it a little bit so that our character can pretty much run on it. To be precise, I'm gonna scale it to 6.35 in the X scale and 1.6 in the Y scale. Now make sure to make the path wide enough so that the player can jump on the 3 lanes. Now let's compile, and in the level let's delete this static mesh and replace it with the floor BP instead. And also make sure to keep the location at center. Let's place the play start a little forward in the path so the player will have a proper ground beneath him. So now let's play and test. As you can see, our player can move around this path without any issue, and the path scale also looks fine. Alright, so now what we want to do is, we want to keep adding paths in front of the previous one at runtime. Somewhat like this, but for that we must know the ending location of the path, means the exact point from where the next path must be attached. So to get that, let's go back to your floor BP, and to get the location of the attach point, let's add an arrow component. Let's name this attach point. And we are going to place it just at the end of the path from where the next path must be attached. This component will help us to get the location of the exact location where we need to spawn the new path. You can see it over here also. Now if you don't have a world settings window, you can search it from here. There it is. And in your world settings, make sure you have this game mode. Let's browse to it, and here it is in the content browser. You can also make a new one by right click, and in blueprint classes, from here you can select game mode paste, but we already have one here, and do not forget to select your game mode in the world settings. Now inside the game mode, we are going to write all the logics about what is happening in the level, like spawning floor, obstacle, coins, and all those stuff. And game mode is the most reliable class to do stuff like this, because it persists the whole level even if your character dies. So let's right click and create a custom event. Let's name this add new floor. Now we will use this event to add new floor in the level. And to do that, search for spawn actor from class. Here it is. And in the class, search for floor PP, which is this one. Now to spawn this actor, it needs a spawn transform. So right click and split the structure. Here you will see the transform is the combination of location, rotation and scale. So how we gonna give it that? So if you remember, we have this attach point component which we created before, and that's what we are going to use to get the transform. But before that, get an event begin play, which triggers at the very starting of the level. Then we are going to get actor of class. This node searches for the instance of a particular actor class in the level. In our case, we wanna get this floor BP. So in the actor class, select floor BP, and when we get the floor BP, we are going to get the attach point component from inside it, which is this arrow. And as I told you, we are going to get the world transform of this attach point, which we will be using to give the position to the new floor BP we are going to spawn. So for that, first let's store this transform into a variable, and I'm gonna call this new floor spawn position. Alright, so once we get the spawn position for the next floor, then we are going to add a new floor. So here just call this event. And here do not forget to use this position to spawn the next floor. Just right click, split the structure, and we just need the location and rotation to spawn a new floor. Although this will just spawn only one floor. Let's play, and here you can see it actually added a new floor. Now instead of calling this event only one time, we can use a for loop and call this as many times we want. Let's say we want to call this 8 times. Now this for loop will call this event till the last index. Now since we are setting this position variable only one time, we need to update it every time we spawn a new floor. So for that, first let's store our floor blueprint into a variable. Let's call this floor BP. Now get its attach point component, then get world transform, and then set the new spawning position. So the floor spawning position will keep updating as we keep adding the new floors. Now let's play and test this. So as you can see, we have 8 new floors added in our level. But still this path isn't endless. Like if we keep running, we will eventually come to the end. But we want to keep adding new floors and removing the previous one as we keep running. And that's exactly what we are going to do now. So for that, come to your floor blueprint and here let's add a box collision component. I'm going to call this destroy box. Now scale this box a little bit according to your path and place the box in the forward direction at a little distance from the path. Now the whole purpose of this collision box is when the player will overlap with it, it will add a new floor in the level and destroy the previous one. So right click on this component and from here add an event begin overlap. Now when anything will overlap with this box, it will trigger this event. So first we wanna check if that overlapped actor is a player character. So get player character, then get a branch. And if it is true, only then we are going to execute the further code. And the thing we want to do is, we want to call this add new floor event from the game mode. So for that we can cast to our game mode, which is a third person game mode, and from here we can call that event. That's the easiest way to do it. And for the reference, we can get game mode and plug it here. And this will just work fine and will add a new floor. And then we are going to destroy actor, where the target is going to be self. Means as we overlap with the box, we are going to destroy this floor itself, which will be our previous floor. But here the casting will be a little expensive for the game performance since we are going to add floor countless numbers of time. And there is a better way of communicating between blueprints, and that is using blueprint interface. So in your content browser, let's create a new folder. Let's call this BP interfaces. Here we are going to keep all our blueprint interface classes. Now to create one, right click in the blueprints, here select the blueprint interface. Let's call this game mode BP interface. Open this up and here let's name this event add new floor. Compile it. Now to use this interface to replace with this event, go to your class settings and right here add a new blueprint interface. Select the interface we just created. Here you go. Now we can use any of the events defined in this blueprint interface here inside our game mode. Compile it first and then we can define this event. Just search for event add new floor just like this. And it will work just like any other custom event. But the main advantage of using blueprint interface is that I can call its event anywhere without any hard reference, as you can see, and we don't even need to cast to a game mode to call this event. We just need to give it any valid indirect reference of that class. So now we can add new floor without affecting much performance. So now let's play and test this. Now if we keep running, we will eventually hit that destroy box, which is going to remove the previous path and add a new floor. And the cycle will keep repeating again and again, creating an endless path. So now it's time to replace this road mesh with a new one. So for that, go to your content browser. Here in your low poly city folder, go to maps and here open up this map. So here you will find these different kinds of roads and other building structures, but mainly we are here to make a road mesh out of these different meshes. Like you can use any of them that you like, but here I'm gonna go with these two specific mesh. So how am I gonna do it is, let's duplicate this mesh and let's scale it a little bit. Let's scale this a little bit on x-axis and a tiny bit on the y-axis. You can copy these scale values since I already know how much I need to scale it, as I've done this before also. And after you scaled it, let's put a character on this road to get the relative idea of the scaling. As you can see, the scaling looks fine. And now let's duplicate this one since this road is for the corners. Let's give it the same scaling as our previous road. Now for the precise placement, let's change the layout of the viewport. We are going to keep the one half to the top perspective. Now let's try to align this road just next to another one. And there is a slight misalignment. You can just simply copy the X location and paste it in another one to align them properly. Now I'm trying to place this road in such a way that these white lines look equally distant. Once I'm done with that, I'm gonna copy this, bring it to another side, Now I have to mirror this mesh to make it look symmetrical. So just right click and under the transform, mirror it to the y-axis. Now just align it the similar way. And there you can see it pretty much looks like the 3-lane road. Now let's select them all and duplicate them to place them in front of the previous one. Make sure there is no gap between them. And then duplicate it once more. And after filling the gap, this is the roadblock we wanted to make, and now we just need to merge it into a single mesh. First let's select the middle roads first, since it is going to decide the pivot location, and then select the other parts. Once you are done with that, go to tools and select this merge actors, and here you can see all the actors that you have selected. Now just click on the merge actors, and here let's select the location. I'm just going to save it in asset, then in flow folder. Let's give it the name road to SM. There it is. Now if I place this into the level, here you can see it is exactly same as this one, but it's just a single mesh. Now the only thing we need to do is, we need to shift its pivot point all the way to starting, just like we did for the previous road we were using in the previous part. So just switch to modeling mode, then in the X form, select edit pivot, and then you can shift your pivot. Move it all the way to starting. And when you are done, just accept, and now the pivot location has been changed permanently. Now let's go back to our third person level. You can save them all. And now we need to replace that mesh with this one. So just go to your floor BP and here change the floor mesh with the mesh which we just created. Just change the scaling back to 1. But the attach point location has also been disturbed because of the scaling. So let's place this again at the end of the road. Instead let's just attach it to the scene root. And set its scale back to 1. There you go. Let's compile. And now if we play, you can see it's looking a lot better than just a plain black texture. Now we want our character to run in a single line, not like so freely like other games. So to do that, let's open up our character blueprint, which is in the third person and blueprint folder. There it is. Now here you can see there are many different inputs for the moment, but we don't really need them, so let's delete them. Now here we just need this move event. Let's unplug this out from this input, and here instead we are going to call this using event tick. The event tick runs every frame, so we will be telling our player to run every frame instead of we just pressing any key. Now here set the y-axis parameter to +1, since this will tell the character to run in the forward direction. Now if I play, you can see the character is running without me pressing any input key. But now we need to adjust the spring arm or the camera boom a little upward, but this doesn't rotate because here in the details we need to uncheck some options first, which are inherit pitch, Y yaw and Z roll. And now we must be able to rotate the camera boom. Also here you can enable the camera lag, which smooths out the camera movement. And now if you play, here you can see the camera view is a lot better now. Now it's time to import character in our game, and for that we have this stylized character kit. You can find this in the marketplace, and it's a really great asset pack which contains different kinds of characters. So just add this to your project just like you did for the previous asset pack. Select the closest version it's compatible with and then add to project. After this, in your content browser, you will see this SCK casual folder, and inside this, if I show you through the skeletal mesh filter, you can see these are all skeletal mesh that comes with this asset pack. Now I'm gonna go with this character to be specific. You can go with any that you like. So what I'm gonna do is, I'm just going to copy this skeletal mesh, and inside the characters folder, I'm gonna make a new folder, and inside this I'm going to paste this character. Now let me rename this character to runner character. Now a good thing with this character is that this is using this UE4 mannequin skeleton, so it is going to be really easy to retarget any animation we want. Now just go to your character blueprint, and here let's select the mesh, and we are going to change the skeletal mesh to our runner character. Now it looks a little weird because it's using wrong animation class. So from here we are going to change its animation class to third person NMBP. Now it looks great. If I show you this NMBP, here you can see it's using this UE4 mannequin skeleton which our runner character uses. So that's why it works correct with this animation blueprint. Now if I play, you can see we have totally replaced our character with this runner character. Now we need to do some little modification in our animation blueprint. So first of all, in animation graph, here we are going to add a default slot. So just search for it. There it is. Now what this do is, this allows us to play animation montage along while we use the animation blueprint. Now inside this state machine, we just only need this idle run state, so just delete rest of them because we are going to play them through animation montage in our character blueprint. Now for the animations, we are going to use one more asset pack, that is sample animation. It was released by Epic Games previous year and it contains 500 free animations which you can use in your own project. Now for this you need to create a project, so let's just create one. Alright, there it is. And here you can see the character movement is really smooth with all the animations because it's using motion matching. But we are not going to use motion matching for our project, we just need to extract some animation from this project. So in your content browser, go into characters, UEF and mannequin, animations, and into this jump folder, here are all the animations we are going to choose from. Now you can choose any of the animations you like and is appropriate for the project, but I've already chosen some of the animations and one of them is this one. So this animation I'm gonna use for jumping into another lane on the left side. Similarly, there is this another animation to jump onto right side. There it is. So what I'm gonna do is, to migrate these animations into our project, let's select both of these animations. Right click and click on show in Explorer. This is going to locate the animation file in your file explorer and from here you can copy them one by one. Then go back to your project and here in the content browser let's create a folder. Let's name this animations since here we are going to keep all of our animations, and right click and show in Explorer and paste that animation file here. Also copy that second animation file and paste it here. There you go. And now if we go back to our project into this animation folder, here you'll see we have both of these animations. Now if we try to open this animation, it will throw us this message telling it doesn't have the skeleton it was using, so we need to assign new one. Just click on yes. Now here we need to pick replacement skeleton. Now our target skeleton is this one which our runner character uses, but still we cannot assign it yet because I've done this before, and when we directly try to retarget the skeleton for this animation, the animation looks a little bit weird. Maybe because skeleton structure doesn't match properly with this one, so we are going to retarget this animation with this SK mannequin skeleton first since it works with this properly. So let's click OK, and now if we open this animation, here you'll see the animation has been retargeted for this skeleton and it looks quite perfect. Now do the same with the second one. There you can see this one has also been retargeted. And now it's time to retarget these animation for our runner character. So just right click, go to retarget animation, and here in the target skeletal mesh, select our runner character. And here we want to retarget these side jump animations, so just select both of them. Then click on export animation. Here select the export location and click on export. So finally there they are. If I open this up, here you can see the animation has been retargeted for our runner character, and also there is no issue with the animation. And now we can delete these SK mannequin animations since they were just a middle source to retarget the animations. Now we need to do the same process for the other animations that we want to import in our project. So I've selected some animations already. You can also use the same animations that I am using. Here I want to extract some jump animations. One of them is this one right here. It's a really good animation we can use for the jump moment in a game. So I'm gonna use total 3 jump animations for a game and randomize between them. So another 2 are these. And also we will be needing a roll animation, so we are gonna use this one. Looks pretty good. Now do the same retargeting process we did for our previous animations. Now after you're done with retargeting, delete these SK mannequin animations since we only need our runner character animations. Now let's organize these animations into different folders. So I've created this jump folder to keep all the jump animation inside this, and then a roll folder to keep this roll animation inside it. Now let's open this side jump animation. inside this we need to make some changes. First of all, we need to disable the root motion so the player will stay at one place while playing the animation, and then we need to trim the unnecessary part from this animation. So if I show you, we want to end this animation at 33 frame. So right after this frame, I want to end this animation. So right click, and from this option, it will remove all the frames after 33. There you go, and now you can see the animation has been trimmed out. Now we are going to do the same with the left jump animation. So just like before, disable the root motion, and at frame 33, remove the rest of the frames. Now let's go to roll animation. Open this up, and here disable the root motion first, it already is, and make sure the force root lock is enabled for this animation. Now it's time to trim the animation. Now in this animation the player jumps from a height and then starts to roll. So we need to trim this from where it starts to roll, which starts from somewhere around 30 frame. So just right click and remove frame in range 0 to 30. There you go. Now the animation directly starts from where the character starts rolling. Now we also have to trim the last part of the animation, which is at around from frame 29. So just remove the last frames, and the rolling animation is also ready. And now it's time to trim the jump animations. Let's open this up. Now I have already wrote down the starting and the ending frames of the animations. So for all kinds of jump animation, it starts from 5th frame and ends at 40. Now before that, make sure you have disabled the root motion, then right click and remove frame 0 to 5. And then remove the last part of the animation from frame 37. There you go. Now you have to repeat the same trimming process for rest of the 2 jump animations, since they also have the same trimming frames. Now after you are done with trimming, now one last thing you have to do is just go to your animation folder, and to do it quickly, in your filter, enable the animation sequence filter. There it is, and after you enable the filter, you'll see all the animations you have inside the animation folder. Just select all of them, right click and make animation montage of them, because we are going to use them to create smooth character movement in the next part of this game tutorial series. And with that, we are done setting up the animations for our character in this game. So at this point of time, we do have all the animations we need, like the jump animation, roll animation, and side jump animation. But if we play, we can't actually do anything except of running. So now we need to implement the character movements. So for that, go to your character blueprint, and here you can see it's pretty much empty. So this is where we are going to write all the logics about the movement. So first of all, let's get the W key input. There it is. So when you press the W key, this will get trigger, and this input is just for the testing purpose. The proper way of setting up inputs will be through input actions and mappings, but we are just gonna use this for now. Later on we are going to switch on the input actions. So when we press W, we're gonna jump. So for that, let's create a separate custom event. Let's name this high jump. And we are going to call this event when we press W. So on press, just call this event. And now we are gonna write jump logic inside this custom event. So first let's create a variable. Let's name this is jumping. Make sure it's a boolean. So when we jump, we are gonna set this boolean to true, so that we will know that our character is jumping. Now what we are going to do, here you can see we have these 3 jump animations. So let's just pick up any one of them for the testing, and make sure you have created the animation montage. If you haven't, you can create it from here. Now to play the animation montage, just search for play anim montage. Here it is. And here you need to select the animation montage you want to play. We have 3 of them, but just for now we are gonna choose any one of them. There you go. You can also select manually like this. Now if we press W, it is going to call this event, and it is going to play this animation. So now let's play and see how it works till now. As you can see, I'm pressing W, and of course it's only playing the animation. We still need to add height movement. So for that, I'm gonna add timeline. There it is. Let's name this jump timeline, and play it from start every time you call this event. Now open this timeline, and here let's add a float track. Let's name this jump track. Now this timeline will be responsible for changing the Z location value of our character, means how much high or low our character is going to jump. Now let's right click and add a float key. Give it the time and value both 0, since we are going to start from the Z location 0. Now let's add another float key, and let's give it the time around 0.2 seconds, and after 0.2 seconds, I wanna give a character the height of 150. Now these value will represent this Z location of our character, and more the value, higher our character is going to jump. Now when a character reaches the height of 150 after 0.2 seconds, then the character will float in the air for a while, for about let's say 0.7 seconds. Let's add a float point here. And after that the character gonna fall off. So let's add a float key and give it the value of 0 at time around 0.95. Now to end this timeline, you can either use the last keyframe, so it will automatically end at the last keyframe, or you can manually adjust the length of the timeline. Now we need to make some curves through these points so that the jumping movement will be smooth. So just right click on the point and select the user. And now you can make curves through these lines. Do the same for another point. Now you can try to make it as smooth as possible. And also right click on the starting point and change it to auto, so you can start jumping more smoothly. Let's just keep the curve straight for this, so the jump will start slowly. So I have adjusted these points a little bit. Now let's go back to event graph. Now here in the timeline, this is what going to give us the output of these curves value, and we are gonna use this to set the Z location of our character. Now let's get the capsule component and let's set its relative location. And while every frame this timeline is running, we are going to set the Z location of this component. So for that, right click and split the structure so we can get each axis separately. And since we only want to change the Z value, the X and Y should remain the same. So get the relative location of the capsule component, then split the structure and connect X to X, Y to Y, and for the Z, we are gonna use the jump track. But using this value directly can cause issues because we need to add the Z location on the current one. So it wouldn't just snap if values doesn't align with the timeline. So we are gonna add this value on the current Z location. And how we gonna get that? So before even this timeline start, we are going to store the player's current Z location. So let's create a variable. Let's name this current Z location and make sure it's a float. Let's set this variable here, and to get the current Z location, we are going to get the capsule component's relative location and plug its Z location to store in this variable. Now you can plug this current Z location variable here to add it with the timeline value, and this added value is going to be our character's jump height. Now let's play and test this. So now when I press W, you can see our character jumps. And the landing seems too smooth to be realistic, so we also have to adjust that. But before that, if you move these 2 points a little bit high, it is going to affect our character's jump height. So now if I jump, you can see our character jumps way too high. So you can customize your character's movement very easily through these timelines however you want. But now I'm just gonna edit this timeline a little bit more to get the result that I expect. So now it looks pretty good, but there is still some problem with this jump movement. Like if I spam the W button, it is just keep adding the height to a character jump. To fix this, we can add a condition here before we call this jump event. So as you can see, we have this isJumping variable set to true when we start jumping. So when isJumping boolean is not true, then only we can call this jump event. And when the jump timeline finishes, we are going to set isJumping to false. So this is how we are going to restrict the input spam. So now if I try to spam the key, it only jumps when the timeline finishes. Now here we are playing this jump animation, but we also have these 2 more jump animations. So what we can do is, we can randomize between 3 of these jump animations. So there will be different jump animation every time a character jumps. So for that, let's get random integer in range. Here it is, and here set the max value to 2. So we will get random integer of minimum 0 to max 2. Now search for switch on int. And let's add pins 3 times. So based on what value we get, that particular execution pin will be fired. Now let's shift these nodes a little bit and connect this here. So if the random integer is 0, then this code will be fired where it will play this animation montage. So let's play different animation for each random number, where we are gonna play this animation if the random number is 1. Make sure you have selected it. Now if the random number is 2, then we are going to play this animation, which is the last one right here, and make sure to connect the pins. So now let's play and test this. So every time we jump, as you can see, it's playing the random animations. So it's working great till now. So as of now, we only have the W input for the character's jump movement. Now let's add some more. So we are gonna add the A key and then we are gonna add the D key. There you go, and both these inputs are gonna call a custom event which we are going to create here. Let's name this side movement, and here we are also gonna add an input parameter, make sure it's a float, and let's name this axis. Now this event will be responsible for the side movements of a character, and we are going to call this event when we press the A key and the D key. If you ever get this error, you can easily fix it by refreshing the node. So now when we press the A key, we are going to tell it to move in the negative axis, which will be our left direction, and on D key, give it the axis value of +1. Now the exact reason we did this, because if you let's say move your character in the left direction, here you can see how the location changes into negative direction, while if you move your character to the right direction, the value is going to be positive, and we can use that to differentiate in which direction we want to move our character. Now more on that later on. First let's create a variable, let's name this side jump and make sure it's a boolean, then set this boolean to true when we call this event so that we'll know we are currently side jumping. And just after that let's add a timeline. Let's name this side jump timeline and play it from start. Double click to open the timeline, and here let's add a vector track. Now we chose vector track because now we want to work on multiple axes, because we want a side jump to change the lane, and at the same time we want our character to jump a little bit, so that's why. Now first of all we are going to set the points for only y axis, so let's lock x and y. Now right click and add a key for y axis. Set their time and value 0 initially. Now add another key point, and this time set the time to 0.5 and value to 200. Now you can select this option so the timeline will end at the last keyframe automatically, or you can manually adjust the length of the timeline. Now you can break this vector track to get each axis value separately. Here we want the y value for now, so while updating the timeline, we can set our character's location. So get the capsule component and this time set world location. Yeah, the world location. Because we are changing lanes, so it's more appropriate to change world location. Now we're gonna keep the x and z axis the same, so get the capsule's world location, split the structure, same for this node, and then connect x to x and y to y, since we only wanna change the y axis value for now. Now don't just use the timeline value directly, since we are gonna multiply it first, and we are gonna multiply it with this axis parameter. Now why we did that? So since I explained you before, the left moment have the -1 value and the right moment have the +1 value for this parameter. And since it's multiplying with the y value, it is going to influence the y value to become negative or remain positive based on the axis value. So let's play and test. So as you can see, it does work technically, like it's changing the lane, but it always starts from the middle lane, since we haven't introduced the concept of lane yet. So we need to update the current lane, so the player should know on what lane it currently is, so that he can move from that current lane instead of middle lane every time. So for that, let's create a new variable. Let's name this current lane and make sure it's an integer. Now we are going to update this current lane value when we finishes this timeline. Let's compile, and here let's set the default value of current lane to 1, and that is because this middle lane is going to be 1, this left lane is going to be 0, and this right lane is going to be 2, because this way it's easier to handle values while coding. Now based on where we moved, we are going to add or subtract the lane value. So here let's check if this axis value is less than 0, that means it's -1, and that also means we have moved left. So in that case, we are going to subtract the lane value by 1. So for that, let's first get the current lane and get an addition operator and plug it here. Now we are going to either subtract 1 or add 1 in the current lane based on where we move. So here, just to avoid the branch, we can use this select node and here plug this return value to addition operator. Now based on if this condition is true or false, we can give it the value for each condition, like return -1 if the condition is true or 1 if the condition is false. So that value will be added and that will set our current lane value. So this is how we are going to update the current lane value. Also set this side jump boolean to false when the timeline finishes. Now it was just about updating the value inside the variable, but now here we have to make some changes to make character change the lane based on this variable value. So here let's add an add operator before we multiply this value. Now here we wanna add the value we wanna move based on the current lane. So get the current lane and get the select node. And let's add 3 pins since we have 3 lanes. Now if the lane value is 0, that means we already have the left lane. So we just wanna add 200 to shift in the middle lane. And on option 1 keep it 0. Then if the lane value is 2, we wanna subtract -2. So then it will add to y value, then multiply to axis and set the world location. One thing to correct here is to set this value to also negative, because of this axis value, the negative will eventually get positive. Now let's also print the lane value to see how it's actually going. So let's play. As you can see, when I'm changing the lane, it's changing the character position from the current lane instead of the middle lane. And on the top left, the lane count is also going like it should be. But there is one issue with this. If we try to go beyond the third lane, the game glitch out and the values also go beyond the limitation. So we can easily fix that just by adding condition before changing the lane. So the condition is going to be that the current lane should be greater than 0. Now we are going to attach one more condition with it using AND operator, and the other condition is that the side jump boolean should not be true. This condition is just to avoid any input spam. Now to change the lane to right, the condition is that the current lane value must be smaller than 2 and side jump should not be true. Now when we press A, we are going to play a side jump animation. Here you can see we have one for left jump and another for right jump. So based on what key we press, we are going to play the animation. So here play anim montage. And here select the appropriate animation for this key. So for the A key, we are gonna play this left jump animation. So select that animation here, and the similar way for the D key, select this right jump animation. Make sure you have selected it, and now let's compile and test this. So let's go left, and as you can see, the animation is working great. And also, I cannot go beyond the limitation of the lanes. So the lane limitation is also working. But now we need to add a slight height jump when the player jumps to the another lane. So for that, open this timeline, and now we are gonna set value for the Z axis. So let's lock X and Y axis, and let's add a Z key point. Initially give it the time and value 0. Then add another one, and let's give this one time of 0.2. And you can give it any value you want or that suits your animation. I'm gonna keep it around 99. Also right click and select user, so you can actually bend the curve to make the movement more smooth. Then add another Z key, then again right click and make it user. And give it the time of 0.5 and value back to 0 since we are gonna land back on the ground. Just make sure all the key points ends at the same time. And also you can adjust the curve to make the jump smoother. Now let's compile. Let's go back to our event graph. Now from here you can access your timeline Z value. Now to make the player jump a little bit, we are going to set the relative location of the capsule component. Relative location because we wanna make the player jump in its local space, because that's more convenient. And just like before, we wanna keep the X and Y axis the same. So split the structure and connect X to X and Y to Y. Now for the Z, we are gonna use the timeline's Z value, but not directly. We are going to add the current Z location on this timeline's Z value. So just like before, we are going to set the current Z value before the timeline starts. And here we are gonna add it with the timeline value. So now let's play and test this. So now as we go right or left, our player jumps a little bit along while moving the side, and it's looking great. And also you can customize the height or any movement by these timelines, so feel free to experiment with these values. Now there's one thing to notice. So when the player lands after jumping, you can see it takes some time to switch back to running. So let's try to fix that. So here let's get a event on landed. So this event fires when a player lands on the ground. So one way to instantly switch from animation montage to normal animation is by using set animation mode. Here you can tell it to use animation blueprint as soon as your character lands. Also let's print a string so that we'll know this event is being called. So now when we lands after jump, you can see it instantly switched to running animation, but we wanna switch smoothly. So let's delete this one, and here we're gonna play a little trick here. We're going to play montage when a player lands. This is a different kind of play animation montage node since we get a lot of options here, and specifically we need this one. Now when we land, what animation we are gonna play? So get current montage and plug it here. Now we are gonna play the already playing montage and start playing it from its ending. And since we know montage automatically blends out the animation, it's gonna create a smooth transition effect between animations. Now how we are going to get the ending position of any animation? So when we play the animation montage, here you see there is this return node which returns the length of the animation and how long the animation is. That number is the last point of any animation timeline. So first we are going to store the length of any animation we play. So for that, let's create a variable and we're gonna name this anim length and make sure it's a float. So let's set it after we play the animation and store the length of the animation. Do it for the right jump also, and we are also gonna do the same thing for the high jump since what we did on onLanded is also going to affect the high jump. So just store the animation length into this variable. Now once you are done with this, you have to use this animation length as the starting position here. And now it will smoothly blend out the animation. So let's play and test this. So as you can see, when I side jump, it smoothly transitioned back to running after the player lands on the ground. And now the movement system is really smooth. So now we are only left with the rolling movement, which we will cover in the next part. So as of now, we can high jump and also side jump to change the lane, and these movements are working pretty good. But now it's time to add the roll movement. So go to your character blueprint where we have wrote all the logics about the character movement. So let's here add a custom event and let's name this roll movement. And then let's create a variable and let's name this is rolling. Make sure it's a boolean and set this true when we are calling this event. So we'll know our character is currently rolling. Then we are going to play our animation montage and make sure to select this one, not the bottom one, since this one is a little different than the another one, although they do the same thing. Now here we also need to tell it on which skeletal mesh we want to play the animation montage. So just plug the character mesh here, and here we are going to select our rolling animation montage, which is this one we have in our content browser. Now here we get a lot of execution pins which triggers on different events. So here on animation completed, we are going to set is rolling to false. Also we'll do the same thing if the animation was interrupted in between. Now we are going to call this event when we press the S key, just like we have set up our other inputs. So right here, let's search for the S key. Here it is. So when we press the S key, first of all, we wanna ensure that we are not already rolling. Otherwise we can get input spam issue. And if we are not rolling, we are going to call that roll movement event. And now when we press S, our character rolls. So it's working pretty nice, but not when we jump. And we want it to snap down to the ground as soon as our character rolls in the air. So for that, first we are going to check if our character is jumping. And if it is jumping, we want to snap it down to the ground. So for that, let's add a timeline. Let's name this roll timeline and always play it from start. Now double click to open the timeline, and here let's add a float track since we only want to change the Z axis. Let's name this snap down track. So here right click and add a key and give it the time and value both 0. Now add another float key and let's give it the time of 0.2 and value of about 200. Now to end this timeline at the last key point, you can select this option, or you can also manually change the length of the timeline. Now this is from where I will receive all those values, and after this, and we are going to set the relative Z location of the capsule component just like we have did for other movements. Copy these nodes and paste it to do it quickly. So XY location will remain same, but here we are just gonna change the Z value that is responsible for up and down movement. Now first, here we are gonna subtract the timeline value with our character's current Z location. Make sure the current Z location is above in the subtract operator and connect the subtracted value to the Z axis. Now here, since we are using this current Z location variable, we also need to set its value before we start rolling. So I'm just gonna copy it from our previous movement system and paste it before you start this roll timeline, where we are basically getting a player capsule Z location. Now also, when you're finished with the rolling timeline, we are going to set is rolling boolean to false again. So now let's play and test this. As you can see, we are getting a weird issue here while we try to roll after jumping, and that is because as we high jump, it plays this timeline, and this timeline is overlapping with our rolling timeline. So we need to stop this jump timeline when we are rolling. So let's create a custom event. Let's name this stop jump timeline and set is jumping to false. and then connect it to stop pin of this timeline. So the timeline will get stopped. And now we need to call that event before we start this roll timeline. So here let's call this stop jump timeline, and this should fix the issue. So let's jump and roll. Here we also got one more issue, and that is because of this on landed event. Since as soon as our character will land on the floor, it is just going to stop and switch back to running animation. So here let's add a condition, and let's say when our character is jumping, only then we are going to blend the animation on land. Let's test this again, and this time it's working. But sometimes while jump and roll, our character literally goes underground. This is because we haven't set any limit on the lower extent. So what we can do is, let's create a variable. Let's name this default z location. Now here we are gonna save our character's capsule's default local z location, and we're gonna do this in the construct script. So the value will be stored already before even we play. So the value we wanna store is our capsule's relative location. Right click and split the structure, and we want to store its z location. Now let's go back to event graph, and here while we are constantly changing the player's capsule location, with that we are also going to check a condition, and that is if our current capsule's z location is less than equals to our default z location. So every time we update the location, it also checks if we already hit the floor, and if we did, we want to stop this timeline. So for that, let's create a custom event, and let's call this stop rolling timeline. Let's connect it to the stop pin, and if this condition is true, we are going to stop our rolling timeline. That will just stop the rolling movement of the character. Now here when we are setting the z location, we are directly plugging this subtracted value to this z location, and there is no limit to it unless the condition we just applied. So we can do one more thing here to ensure that glitch never happens, and for that let's search for the clamp float, and this is used to limit the value. So here we can provide it the minimum and maximum value. The minimum value we can ever get after subtracting is the default z location of the character, and the maximum can be, let's say, around 1000, and plug this return value to the z axis. So let's play and test this. And now as you can see, no matter how much I try, the player never goes under the floor. Now after all this, if you're getting the problem where this side jump animation does not switch to run animation as soon as you land, then in that case, a quick solution to that will be when you finish the timeline, what you can do here is that what we are already doing here on landed event, which is blending out the animation montage. So just copy and paste it here. So as soon as you finish your timeline, you are going to blend out from the current playing animation montage. Just make sure you are setting this anim length variable wherever you are playing that animation. Now since we are not getting any blending issue, then we are not gonna use this. Now one more issue you will notice, that when you jump and then side jump, you will see your character will get a double jump, and since we don't want that, we need to fix this. So in your side movement event, if you'll come here you can see this is making our character jump, and we need to block that if we are already high jumping. So let's add a condition here, and for that let's create a variable. Let's name this can jump. Make sure it's a boolean, and here if can jump is true, only then we can jump while changing the lane. Now how is this condition gonna vary? So for that, let's come here. Before we start this side jump timeline, let's set this boolean and get is jumping boolean, and if it is not true, then we can jump. That just means if our character is not high jumping, only then we can jump while changing the lane. Now there is one more thing that we need to fix that can cause the problem, that is when we side jump and when we high jump, there is a common variable that is being used in both the moment. That is this current z location, and if we try to do both the moments at the same time, it can cause the issue. So to avoid that, here let's add a condition that if our character is jumping, in that case we are not going to change the value of this current z location. We are only going to set its value when we are not jumping. But we are using this variable right here that helps the player to jump. So what we can do here is get is jumping boolean, and depending on if it is true or false, we are going to replace the current z location variable with default z location. So search for the select node. Here it is. If this variable is false, then we are gonna use current z location, and if it is true, we are gonna use default z location, and whichever the condition is true, that variable is going to get added. So now let's play and test this. So now as we jump, you can see there is no double jump issue, and the movement is working quite smoothly. Now there's one more issue. After jump, when we are in the air, if we quickly roll and move side, you can see in that case, we are still able to jump mid-air. So it's really easy to fix that. We just need to add one more condition here for is rolling. So is rolling should also be not true to make can jump condition true. And to combine both of these conditions, we can use AND operator. So now if I try to do that again, it's not happening and that problem is being solved. But now there is one more issue that if I move side and then jump, I get a double jump. So we also need to fix that. So for that, here when you press the W key, we need to add a condition. Let's get an AND operator first since we already have a condition here. Now that other condition is the side jump should not be true. So if you're not already jumping and you're also not in the middle of the side jump, then you will be able to high jump. So let's test this now. So here I'm moving side and also trying to jump mid-air, but I'm not able to because of the condition we made. And now there is one more issue left, that if I quickly roll and jump mid-air, I will be able to do that again and again. That can easily break the game. So to fix that, we need to add one more condition here. So for that, get your character movement, and from that, get is falling. Here we just wanna check if the character is not already falling and is somewhere in the ground. So if this condition is not true, then only we can high jump. Add a pin here for this condition and plug it to operator. So now let's test this again. So I'm trying to do that again, but it's not happening no matter how hard I try. So this issue is also being resolved. Now there are some more things you can do to avoid any glitches in this character movement system. So that would be, before we high jump, we can make sure that the rolling timeline is not working. So for that, before we start the jump timeline, we are going to stop the rolling timeline. There you go. And also in your on-landed event, when you land and you were jumping, make sure to stop the jump timeline. Now let's add a sequence. Since we are gonna do one more thing here, is that we are gonna check if we were rolling, and on landed, if we were rolling, then we are gonna stop rolling movement. So that is much about the character movement system. And one last thing I would suggest is to speed up the animation a bit. So let's open the animation sequence of the rolling first, and let's set the rate scale to 1.2. And as we change the rate scale of the animation sequence, the animation montage automatically get affected. So don't worry about that. So now let's change the rate scale of the side jump animation. I'm gonna give it a rate scale of 1.3. Same for the right side jump animation. There you go. Now let's play. And as you can see, the side jump and rolling animation are a little bit speed up and looking pretty good. And we have also fixed all the glitches of the character movement system. So as of now, we can jump, roll and move right left. And the overall movement system is quite smooth. Now before we increase the player's speed gradually, we first need to implement calculating distance, because speed is correlated to distance. So first we need to do that. So first we need to create a user widget for that, and for that let's create a separate folder and name it user widget. And inside this, let's create a user widget, which is under user interface and widget blueprint. Let's name this main hood UI, since this is where we are gonna keep all of the UIs we wanna show up while playing. Now first of all, let's add a canvas panel, and inside that, let's place a border. This is going to act as a background border to show the text on. Let's resize it a bit. And let's give it a bit a dark color with the half transparency. Looks fine. And also do not forget to set the anchor at the right place, so it will stick to the corner. Now we wanna add like 2 text inside this border. So for that, we are gonna use a horizontal box. Make sure it covers the whole border, and then let's add a text. Let's align this text to the left corner and vertically at the center. Now let's set the text as distance. Now you can also add a padding to the left side to shift it a little away from the corner, like this. Also let's set its size to 30. Now let's add another text and give it the size of 35. Then let's set the default text to 00. Align it to center and make sure the size is filled. So now no matter how long your text is, it will always stay at the center. As you can see that. Now let's rename this text. Let's name this distance value txt, and make sure here is variable option is checked so that we can edit its value in the blueprint. Now let's open up your game mode, and this is where we are gonna display our main hood UI and update the distance. So at the begin play, we are gonna execute two different codes. The first one is spawning the floor and the other one is creating a main hood widget. So get create widget, here select your main hood UI, which is this one, and then let's promote this return value to store the reference of this widget. Let's name this main hood UI and add it to the viewport. So this is going to display the widget on the player screen from the starting. So if we quickly play and test, you can see we have that widget on the player screen. But now we need to update that text to calculate the distance. So for that, let's create a custom event. Let's name this update distance. So inside this custom event, we are going to write logic about updating distance and the text. And we are going to call this event just after we create this widget. So as we create the widget, we are going to start updating the distance. Now before we create this widget, we need to do one more thing. That is, we need to get the reference to our runner character, which is this one. So for that, let's cast to our third person character. And to plug it here, we need to give it a reference. So get player character and plug it here. Now as we cast, let's promote this to variable to store the reference of the character. Now as we cast, the character reference must be stored inside this variable, but there is a chance that this cast can fail. So in that case, let's add a very short delay of 0.01 seconds and plug it back to casting. So if we fail the cast, after 0.01 seconds, it's gonna try again until the cast succeeds. And when it succeeds, we can create our main hood UI and do other stuff. So now let's finally update the distance. So to do that, let's set a timer by event. And to this event pin, just add a delegate for this event. And let's name this add score. Let's set the time to 0.1 and set this to looping. Now what this timer will do is, it will keep calling this event every 0.1 seconds in a loop. And as it keeps calling this event, we are going to update our distance. So for that, let's create a variable. Let's name this distance. And let's make this integer since we don't want any decimal values in the distance. And let's set it here. Now how we are gonna set the distance value? So let me show you that. So this is our player start. First of all, make sure its X location is at 0. You can shift the road a little backward just so it won't create any problem. Now at this player start, a character will spawn, and as he keeps running straight, the X location value will increase. And this X location value is going to be our distance. So what we are going to do here is get your character reference and get actor's location. Right click and split the structure, and here we want the X location of the character. Let's round this value, and we can use this value as our distance, but it's a little bigger value, so let's divide it by 10 and then set it as a distance. So this way we are going to set the value of our distance, and this will repeat every 0.1 seconds in a loop. Now after we set our distance value, we need to update this text. So to do that, get the main hood UI reference, and here we wanna access this distance value text. So just search for distance value text, here it is, and we are going to set text to change the text value. Now in this text parameter, we are going to give it the value of this distance variable. So here we converted the integer to text, and just make sure to set minimum digit to 2, otherwise it will start as a single 0 rather than a double 0. So that looks better, I guess. Also, you can promote this timer to a variable. Let's call this distance timer. So now let's play and test this. And as you can see, the distance value is getting updated and showing up correctly in the UI. And now we need to work on increasing player speed as the distance value increases. So for that, let's create a custom event and let's name this increase player speed. Let's set timer by event. And let's promote this timer to a variable. Let's name this player speed timer. Now from this event pin, let's add a delegate and let's name this update speed. Now we are going to call this event every 2 seconds in a loop. Now to update the speed of the character, get the character reference, and from this get the character movement component, and from this component set max walk speed, and this value is responsible for the speed of a character. Now we are going to set the speed value according to the distance value, means more the distance, more the speed. So get the distance, and let's first convert it to float, and from this search for map range clamped. Now this node helps you map the value according to the input you gave. So for suppose you need to map the value that is between 1 and 100, and you want to map the value between 1 to 10, and let's suppose you give the value 50. So for 1 to 100 if the value is 50, then for 1 to 10 the value must return 5, and that is how it maps the value. So in our case the base value is distance. So if the distance is between 0 to 1 lakh, then it must return the value between 20 to 5. Yeah, I did it in a reverse order. So more the distance, less the value. Now what we are going to do with that? Let me show you. First get the character movement component, and from that get the max walk speed, and we are going to add this value with our mapping value. And that's how we are going to update our character speed. So overall, more the distance value, less the value we are going to add in our player speed. Now to make this a little bit cleaner, let's move it inside a function instead. So create a function, let's name this calculate player speed, and here just paste the code. Now get a return node, and here we are going to return this addition value. Now just call this function here, and to remove these execution pin, just make it a pure function. There you go, and now we just have this return value which we can directly plug here. Now there must be a limit to add the speed to the character. So for that let's create a variable. Let's call this max player speed and make sure it's a float. And inside this variable we are going to store the maximum speed of the character, and I'm gonna set it to 2000. Since it's enough for our character, I guess. Now we are going to compare it with our player's current speed. So if our player's current speed is greater equals to the max player speed, in that condition we are going to set the current speed to max and then stop calling this timer. So for that get the player speed timer, then clear and invalidate the timer. And this will stop this timer to call this code again and again. Now let's also print the current speed of the player as we keep updating it. So now let's call this event after we update the distance. And now let's see how it works. So in the top left corner of the window, you can see it prints the current speed of the player, and it keeps updating every 2 seconds, and as per the logic, it will go up to max 2000. So it's been around 1.5 minutes and it's still increasing the speed of the player, and right now you can already see how fast our character is going, so it's working fine. Now one more thing we need to do here is just go to your character blueprint, and this is where we have implemented all the character movements logic. So in the side movement event, here right before the timeline, let's make some space. So here what we want to do is, we want to increase the speed of this timeline according to the speed of our character. That means the faster our character will run, then the faster it will move sides, cause in the long run, it can cause issue to tackle the obstacles. So you can get the side jump timeline from here. So it's literally this, and then search for set play rate. Now the default play rate will be value 1. So any value above this is going to increase the speed of the timeline. Now we are going to decide the rate value according to our character's speed. So get the character movement, and from this get max walk speed, then get the map range clamp. And if the speed is between 1000 to 2000, it is going to return the value between 1 to 1.2. And that is how we are going to set the play rate of the timeline. Now to spawn obstacles in a game, first we need to import our asset pack into our project. If you have your own 3D models, you can use them without any doubt, but just for you guys, I'm gonna show you how you can import an asset pack and use the assets as an obstacle in a project. So for that, let's go to Fab, and here let's search for construction. In the filter, go to price, and let's set this to free. So this will display all the free assets available in the marketplace. Now we want this one to be specific, since this has many assets that we can use as obstacles. So let's add this to our project. Now in your project, in the content browser, you will find this construction volume 1 folder, and inside this, if you go into the mesh folder, here you will find all the assets that comes with this asset pack. So here we are gonna select some assets that we are going to use as obstacles. So you can use exact one I'm using, or you can also choose on your own. So I'm just going to copy these assets, and let's go out here, go into the asset folder, and let's create a new folder here. Let's name this obstacle, and inside this I'm gonna keep all the obstacle assets that I'm gonna use. So let's paste them here. There you go. And if I place them into the level, here you'll see their scaling is also perfect for a game. But now I want one more obstacle, for which our character have to roll down to pass through it. Somewhat like this. but it's too wide and its height is also too low for our character to pass through. So what we are going to do, we are going to make our own. So let's select these two assets and drag them into the level. Now try to reassemble these assets to make it similar to that previous asset. Now I'm gonna scale this pylon to 1.5 so its height will be a little bigger, and let's duplicate one more and move it to the side. And I'm also going to scale this to make it fit with these two pylons. So giving X scale of 0.9, and to make it a bit broader, let's give it Z scale of 1.7. So I think we are done with the assembling, and just for the reference, let's place our character in front of this obstacle, and the height looks fine to me. So let's finally select all of these and merge these meshes to a single one. So for that, go to tools and here select this merge actor option and click on merge. Let's save this in our obstacle folder. So the asset must have been saved. Here as you can see, it's in our content browser. Let's place this in a level, and as you can see, it's a single mesh. Now one last thing we need to do here is, we need to adjust its pivot point. So first let's place the asset at location 0. So now let's go into the modeling mode. Here go to X form and edit pivot. Place the pivot at the center point and also at Z0. Now let's accept, and the pivot point has been changed permanently. Now let's clear up the path since we have set up all of our obstacles, and now let's rename these obstacles name. Let's name this one obstacle1 underscore SM, and just like this rename all of them. So after you're done with all of them, let's go to blueprint folder, and here let's create a new folder and name this obstacles. And inside this, we are going to create a blueprint class of actor type, and we're gonna name this base obstacle BP, since this is going to be a base blueprint class for all the obstacles we are going to have in our game. So let's open this, and here let's add a static mesh component. Let's name this obstacle mesh, and from here we can select any of the obstacles that we just made. And in this base class, we are going to write all the logics about what will happen to the character if you hit the obstacle and all that stuff. But since this is a base class, we don't need to actually give it any static mesh, since we are going to do it specifically in its child class. So rather than just keeping it empty, I'm gonna set the static mesh to, let's say this. Doesn't really matter since I'm gonna use an obstacle mesh in the child class. Now let's add one more component, that is arrow component. And this will help us know which is the forward direction for our obstacle. Make sure it's not a child of any component. And to see this clearly, let's change its color to blue. Yeah, it looks fine. Now let's add another component, that is a box collision component, and let's name this death box, because if our character will overlap with this box, then our character is going to die. For now, just place it like this, because all the changes and modification we are going to do in the child classes. So now let's create child blueprint of this class. So for that, you can right click, and from here you can directly create a child class from here. Or the second way is create a blueprint class separately, and here in the all class search for this base obstacle BP. Here it is, select this, and this is how you can make the child class of any blueprint. Let's name this obstacle1 BP. Open this up, and here you'll see it's exactly like its parent class because all the things are inherited from there. Now in its child class, let's set the static mesh to our obstacle1, just like that, and we need to make obstacle classes for each obstacle mesh we have in our game. So just duplicate this blueprint and rename this to obstacle2, and do the same for how many obstacles you have in your project. Open this up and select the corresponding obstacle mesh, and do the same thing for all the obstacles you have in your project. Now after you're done with all the obstacles, so you don't need to write logics for each of these blueprints individually. All you need to do is define all the logics in the base class, and the same functionality will be inherited for all of them. So that's the main advantage of using inheritance. Now we will write the obstacle logics in the next part, but now we need to spawn these obstacles into our level. And to do that, we are going to do that in our game mode. So open the game mode, and this is where we write all the logics about all the things that are happening in a level at runtime. So what we need to do here is, let's create a variable and let's name this obstacle classes. And in the variable type, search for the base obstacle BP. And this is the parent class that we created before, and select the class reference. And let's make this an array, so it will contain multiple classes. Now let's compile, and right here you can see we can add array elements. So what we are actually doing here is we are storing these obstacle classes that we just created into that variable so that later on we can choose between them to which one to spawn. Now I have added 4 elements since we have 4 different obstacles in our project, and in each element I'm gonna select individual obstacle. There you go. And now what we want to do is we want to get a random element from this array that will help us to spawn random obstacle in our level. So for that we are going to create a function, and let's name this get random obstacle. Now get obstacle classes here, and through this get a copy, and through this node, based on what index we provide here, it is going to return us that element from inside that array. For suppose if we provided 0 index, it is going to return us this obstacle class. If the index was 1, it will return us the second element, and if it was 2, it will return us this class, and so on. So what we can do is we can get a random number between 0 to 3, and that will give us the random obstacle class. Now first let's get the length of this array, that means how many elements there are inside this array. So get the length, and we are going to subtract 1 from this length, and this is going to give us the last index of this array. And then we can get random integer in range, and here plug this -1 length value to the max attribute, and through this we will get a random number between 0 to 3, and regardless of how big your array is, it is automatically going to adapt that. So now let's get a return node so that we can return this value, and whatever the random obstacle class we get, we are going to return that value through this function. Now also make sure one thing, to make this function a pure function. So whenever you want a random obstacle class, you can just drag this function like this, and all you get is a random obstacle class. Alright, now we need to write logic about spawning these obstacles. So for that, let's open up your floor BP, and on this floor we want to spawn obstacles. So for that, let's create a custom event, and let's name this spawn obstacle, and here let's add an input parameter, name this obstacle class, and in the variable type search for base obstacle BP, select the class reference, then create another input parameter, let's name this one lane number, and make sure it's an integer. So in order to spawn any obstacle, we will be needing these two parameters, and here we will write the logic about spawning the obstacles. Now we are going to call this event in our game mode when we are adding a new flow. So in order to call that event, first get the floor BP reference, and through that we are going to search for spawn obstacle event. There you go. Now the obstacle that we want to spawn is, for that we have already written a function that gives us random obstacle every time. And for the lane number, we can get random integer in range, because there are 3 lanes like 0, 1 and 2. So here the minimum will be 0 and maximum will be 2, and plug this value here, and this will give us a random lane each time. Now let's go to this event, and before we write the logic, first we need to do something here. That actually we need to get the location of the spawn points, like where we want to spawn the obstacles on this floor. So for that, let's add an arrow component, and let's name this spawn point 1 and drag it under the floor mesh. So here it is. Let me drag this all the way towards the end of this flow, just like this attach point. Now the reason we did that we want this spawn point to be exactly at the center of this flow. So for that, we can just divide this X location by 2, and here we go. This arrow component is exactly at the center of this floor mesh. Now it's not quite visible, so let's change the arrow size a bit. There you go. Now let's duplicate this spawn point 2 more times, since we want to plot them for each lane. And after you have duplicated these spawn points, just place them into their respective lane. There you go. And now we can get each of their location based on the lane we want to spawn an obstacle, and spawn it exactly at that point. So for that, from this lane number parameter, get the select node and add one more pin here since we have 3 lanes, and then plug your spawn point for each of these options. So depending on the lane number value, if the value is 0, we will be using spawn point 1. If it's 1, then use this, and if the value is 2, then use this. So based on the value we get, we use a different spawn point, and we want to get its relative location. And that's where we are going to spawn our obstacle on the floor. Now to spawn the obstacle, we can just simply spawn actor from class, but there is a better way than this in this situation. Instead, we are going to add a child actor component. Now what is that going to do? Well, it's just like you are adding a child actor component like this. And let's say from here we select our obstacle blueprint. let's say this one, and that will be placed at any of these spawn points. And the advantage of doing this is, let's say when we destroy this floor, all the child actors attached to this floor will also be destroyed along with that. So we don't need to destroy these obstacles manually. So this way is way better than spawning actor class. So that's exactly what we are going to do, but at the runtime. Now since we have this relative location, so we can make transform to get location, rotation and scale separately and connect this to relative location. Now from here, set child actor class, and the class that we want to set as a child actor is our obstacle class. So this is how we are going to spawn our obstacle. So let's play and test this, and as you can see, we have random obstacle in our level, so it's working fine. And one last thing we need to do is go to your base obstacle BP. Here just rotate this mesh 180 degree. Otherwise we're gonna see obstacles from their backside rather than front. So this is how we can spawn obstacle in our level. So in the previous video, we were able to spawn these random obstacles in our road, but if our character collapses with them, then literally nothing happens. Like it just blocks the pathway of our character. But we want that when we collide with these obstacles, then our character dies. So for that, let's go to our base obstacle BP. And here, when our character will overlap with this death box, then our character will die. And don't worry about its placement for now, we are gonna change it in its child class. So right click on this death box, and from here, select this on component begin overlap. Now this event will trigger when any object will overlap with this box. So first of all, we wanna ensure that the object that overlaps with this box is a player character. So here we're gonna check that this other actor is equals to our player character. So get player character. So to check this condition, get a branch, and if it is true, our character is gonna die. So for that, let's go to your character blueprint first. And inside here, let's create a custom event. And let's name this death. So in this custom event, we are going to write the logic of death system. So we are going to call this event when this condition is true. And since that event exists in our character blueprint, so we need to cast to our character blueprint in order to call that event. And through this cast, we can call that event. There you go. So when we overlap with that box, we are calling this death event. But here the thing is, we are calling that event through the casting. And casting is a bit expensive performance wise, and we have a better way to communicate between blueprints. And that is using blueprint interface. So in our content browser, let's go to BP interface folder, which we created earlier. And here let's create a blueprint interface, just like we did for the game mode. And let's name this character BP interface. Then open this up. And here let's name this function death. Now let's go back to our character blueprint, and here click on this class settings, and down here in the details panel you can add the blueprint interface. So just search for the character BP interface which we just created, and now we can define this function inside our character blueprint. So here just search for the event death. There you go. You can see it just seems like any other custom event, and we can define the logics just like we do. And the main advantage of using blueprint interface is that we can call this event anywhere without giving it any hard reference. And here we just need to give it a player character reference. And as you can see, now we can call that event without casting to our character blueprint. So after we overlap, we call this death event, and in this death event, now we can start writing the logic. So before that, select your character mesh component, and here in the detail panel, scroll down to the collision section. Here in the collision preset, we need to change it to ragdoll. Like if you want a ragdoll effect when a character dies. So rather than changing it from here, we are going to do that at runtime. So for that, get mesh and search for set collision profile name. Here it is. And set the profile name to ragdoll. So this will just basically do the same thing. And after that, we can set simulate physics, and make sure to check this simulate option. So like all the forces in the world will take over our character, creating a ragdoll effect. And after this, get character movement component and disable movement, so that our character won't be able to move after it dies. And also get player controller and disable inputs, so the player won't be able to receive any inputs from the user. So this is how our character death system is going to work. Alright, so now what we have to do is, here we have to place this death box in the correct position in each of its child blueprint. So the character will die only when it hits the obstacle in the right place. So let's open up the first obstacle, and here let's scale this death box according to the obstacle size. Now make sure to shift this death box at the front of the obstacle, otherwise if it's at the middle and if our character jumps from above it, there's a chance it can hit the corner of this death box, which is like very unfair death of the character. So just make sure to shift it at the front. Now when you're done with one, then do the same with other obstacles. So as we are done with all the obstacles, let's play and test this. So let's see what happens when a character collides with this obstacle. Okay, there is no ragdoll effect, but the inputs and movement are already disabled. So that is happening because we haven't made any physics asset for our character yet. So go to your character mesh, right click, and from here create and assign physics asset to your character. And there you go. You can also modify these capsule collisions for your character body, but I'm just gonna go with default. And now when a character collides with any obstacle, there you can see we have this ragdoll effect that just looks like our character died. Now there is an issue with the obstacle, which is right this one, through which we have to roll. And we cannot roll through this since there's also a death box in front of this obstacle. Now to resolve this issue, let's go to our base obstacle BP, and here let's create a variable. Let's name this must roll. Make sure it's a boolean, and since we created this variable in the parent class, we can access it in any of its child class. So let's go to the obstacle 4 and set this variable to true for this obstacle, which is this one through which we have to roll. So for rest of the obstacle, the must roll variable is false and only true for this one. Now we did that so that we can identify these rolling obstacles separately from others to write a different logic for them. So go to your base obstacle PP and here check if this must roll variable is true or false. If it is false, then a character is just going to die as it should be. But if it is true, then we know that our character must be rolling in that case. Otherwise, it won't be able to pass through that obstacle. So to know if our character is rolling or not, we can use this isRolling boolean to check if our character is rolling. And here based on that, our character will either die or pass through the obstacle. But using this variable can create a lot of problem. Let me show you why. So in your content browser, let's go to our rolling animation and open this up. Now technically the rolling starts from here, even if our character is standing in this position. So how can the player pass through if the player is like this, right? And that isRolling boolean is true even if the character is like that. So instead, what we are going to do is, let me open the animation montage. So what we are going to do is, we are going to check if this animation montage is under a certain timeline. Like let's say, player can pass through the obstacle if the animation is any after the frame 3. So like to mark this, what we can do is, in the notifies, we can right click and from here we can add a montage notifier. Let's name this notify roll start. Now the rolling timeline should end somewhere around at the 17th frame, since after this our character starts to get up. So just like before, add a montage notify and let's name this notify roll end. So now we have these two notifiers, and to know if we are between them, let's create a variable inside your character blueprint and let's name this roll enough. Make sure it's a boolean. Now we are going to set this boolean to true or false based on if we are under these notifiers. So for that, in your roll moment, here when we play this animation montage, here you can see we have this execution pin which triggers on when it hits any of the notifiers. So using that we can update our boolean. Now for that, let's create a separate custom event and let's name this update roll enough boolean. Now to know at which notifier we are, we can use this notifier name value. So for that, let's add an input parameter. Let's name this notifier name and set the variable type to name. And from here search for switch on name. And from the detail panel, let's add two pins since we have two notifier names. The first one is roll start and the second one is roll end. Now here based on which notifier we hit, we are going to set this boolean. So set the roll enough to true when the roll starts and set it to false when the roll ends. Hope it makes sense. Now let's call this event here on notifier begin and also give it the notifier name. So now based on that, it will change the boolean value. Now after this, we want to access this variable right here to check if we are rolled enough. And to avoid casting, let's do it using blueprint interface. So here let's add a function and let's name this get is rolled enough and give it an output parameter and make sure it's a boolean. Now here in your character blueprint, you must be able to see this blueprint interface here. So double click to open this and here in the return node, we are going to give it the value of rolled enough boolean. And through this blueprint interface, we can access that boolean without casting to our character blueprint. You just need to call that blueprint interface function, that is get is rolled enough. And here in the return value, we have that boolean value. So now let's check if we are rolled enough or not. And if we are not rolled enough, then we are going to die. But if we are rolled enough, then what we are going to do is get obstacle mesh and here search for set collision enabled. And set this to no collision, means we are removing any collision from that obstacle so a player can easily pass through it. So now let's compile. Oh, okay, so we haven't plugged any target to this event. Since it's a blueprint interface, it don't need a hard reference, so we can just give it this character reference. And now compile, and there you go, let's test this. So let's try to roll through this obstacle, and as you can see it's working. And this is a simple one, just jump. And for this next one, let's try to roll lately and see what happens. There you go, our character dies. So now we can roll through the obstacles. And one more thing I would suggest is, go to your base obstacle BP, select your obstacle mesh, and here in the collision section, change your collision preset to custom, and for the camera set it to overlap so that the player's camera won't be clipped by these obstacle mesh, like when we jump or roll through them. Alright, so now we want to make platforms for this road path. So go to your construction volume folder and inside this go to mesh folder, and out of all of these meshes you can use any of them to make a platform. But here I'm gonna select this one. Let me place this into the level. So we can use this asset as a platform on which our character will run. So let me scale this a bit. So this looks great, I guess. And this platform is somewhat going to look like this. And to climb on it, we are going to use this wooden plane. Let's place this in front of this and let's rotate this so that our player can climb onto it. Yeah, somewhat like this. And now it pretty much looks like a platform on which our player can run on. Alright, now let's delete these boxes. And now here what we are going to do is, we want to save this asset as it is, as its default orientation. So for that, just select this, go to tools, and here click on this merge tool option. And here click on merge actor. Even though it's just a single asset, it's still gonna work. Now here let me create a separate folder to keep all of our platform assets. And let's save it here. Alright, now if I place this asset into the level, here you'll see its default orientation is just like we set it before. And if I replace it with this, you can see it's just exactly like that. Alright, now we need to edit its pivot to the center. So first let's set its X location to 0, so it's a little easier to edit. Now go to the modeling mode and here go to X form and click on edit pivot. And now you can shift your gizmo to the center and also set the Z location of the pivot to 0, so it will always stick to the ground later when we spawn it. And when you're done with that, click on accept and the pivot has been changed permanently. Now we are also going to do the same with this box. So select and click on merge actors and save it in that folder. And there you can see its default scale is set to what we changed before. And for this asset also, we are going to edit its pivot at the front. Make sure to shift the pivot at the front and widthwise at the center, because this pivot position matters a lot when we are going to spawn these platforms. So we are done with editing the pivot point and its position has been changed permanently. Now similarly, you can make as many as platforms you want for your road path. Like I'm going to go with this. Let me scale this according to our road. There you go, looks great. And for the ladder, to climb up on the platform, I'm going to use this one. Let me rotate and scale this a bit too. So now it looks aligned for this platform perfectly. And now do the same process for what we did for the previous platforms, means the merge tool and editing the pivot. So when you're done with that, let's go to the blueprint folder and here let's create a new folder and let's call this platform. And here we are going to create a blueprint class of vector type and we are going to call this base platform BP, since this is going to be a base class for all the platforms we're gonna have in this project. Now here let's add a static mesh component and let's name this platform mesh. Now let's duplicate one more and let's name this ladder mesh. Now in this one, let's select that wooden stair we were using for that wooden platform, which is this one. And for the platform mesh, let's select the platform, which is this one. So let me place this in the right location like this. And what we want to do here is, we want to keep adding this platform mesh one after another, like according to how much platform length you want. But rather than doing this manually, we are going to do it with logic. Now for that, I need to have the end location of the platform to which I want to add another platform. Like it is just similar to how we did with the floor BP. Like here, if you remember, we have this attach point, and using its location, we add another road next to it. So we are going to do something like that, but we are not going to add any component for that, since we're gonna add multiple platform mesh in a single blueprint. So how are we going to get that location? So to do exactly that, open up your platform mesh, and here go to your socket manager. If you don't have this window here, you can get it from the window tab right here. So here let's add a socket, and let's name this attach point. Now its default location is where your pivot is, so we are going to drag it all the way to where your platform ends, like this. So now let's go back to the platform blueprint, and we are going to do the same with our ladder mesh. So open up its static mesh, and here add a socket. Keep the name same for all the sockets, that is attach point, and then drag it to its end location. Think of it as the point where the next platform is going to get attached. So after you're done with this, go back to your base platform BP, and here instead of manually placing this platform next to this ladder, we are going to do that in the runtime. So let's give it the default location, and we are going to attach it in the construct script. You can think of it as event begin play, but the code inside here starts working before even you hit the play button, like in the editor itself. So what we want to do here is, we want to set the location of the platform mesh to this ladder mesh attach point, right? Which should be around like here. So to do that in blueprints, get the platform mesh, and here set the world location. Now here, why are we using the world location instead of relative location? Well, that is because ultimately we are going to place this platform mesh into the level, right? And all the attachment code that we write in the blueprint is only gonna work if we code in the context of the world location. Alright, now what we want to do is, we want to get the location of the socket that we created before. So for that, get the ladder mesh, and here search for the get socket location, and the socket name was attach point. So plug this to the platform mesh location, and now after we compile, here you can see the platform has been attached to that socket point of the ladder mesh. Let's adjust the point a little bit so that the gap will be perfect. And after compile, as you can see, the gap has been filled. Now we are going to do the pretty much same thing to add platform mesh one after another. And to control that, let me create a variable. Let's name this platform length, and make sure it's an integer. And let's say its default value is 1. Now we want to add a platform mesh right here at this location, and to get that location we have this socket point, right? So get platform mesh, then get socket location. The socket name was attach point. Now right click and promote this to a variable, because we are saving the attach point location for the next platform into this variable, and let's name this last platform attach point. Now we have the location where we want to add our next platform. How are we gonna add it? So just like how you add a static mesh component from here, the similar way to do it at the runtime, search for add static mesh component. So this is how we add a component at runtime, and then search for set static mesh. And the mesh we are going to give it is a platform mesh, since it's the same mesh that we want to repeat. So get its static mesh and plug it here, and the same mesh will be assigned to the next platform. And then we need to give it the location to the attach point. So set the world location and give it this attach point location. Let's compile, and here you'll see now we have two platforms in our blueprint. The one that we already have there, and another that we add at the runtime. But now we want to add multiple platform mesh like this. So for that, let's add a for loop here. There it is. And let's set the last index to 5. So now what this will do is, it is going to call this code 6 times one after another, since the loop starts from index 0 to 5. And as this loop runs, it is going to add 6 more platforms in our blueprint, but at the same location, since we haven't updated this attach point location after every time we spawn a new platform. So let's update this attach point location every time we add a new platform, and the location is going to be the socket location of the new added platform. So from here, search for get socket location. The socket name is attach point, and update it here. So now let's compile. If you go to the viewport, here you can see we have these 6 platforms one after another, but it's very constant, right? Like, what if we want to change the length as much as we want? So to do exactly that, get the platform length variable which we just created, and we can use this as the last index, but instead we need to subtract 1 and then plug it to the last index, because the index starts from 0. And now as you see, we have 2 platforms in our blueprint, even though the length value is 1. So here instead let's start the index from 1, since we have the 1 platform that we added manually. Now you can see it syncs with the value of our variable, and now we can control the length of this platform using this variable. And that's so cool. Like if we want to add 50 platforms, there you can see we added them really quickly. So let's keep the default value to 3. Now one thing that I want to show you is if you place this platform into the level like this, and now you want to control the length of the platform, what you can do is set this length variable to instant editable and expose to spawn. And now in your level you'll see from here you can control that variable value. That's so cool. But unfortunately we don't need that feature, so let's uncheck it since we are going to spawn this platform at the runtime, so we don't manually decide the length of the platform. So instead set the platform length here and we are going to give it the random value. So get random integer in range. Let's give the minimum length around 4 and maximum to let's say 7. And this way we will get random length of the platform each time. You can already see that in the viewport, like when I compile every time I get a random length. Now since this is a base class for the platforms, we are going to create the child class of this blueprint. Let's name this wooden platform BP and then duplicate this and let's name this one concrete platform BP, like since we have 2 platforms in a game. Now inside the base platform, remove these staring mesh from these components since we are going to do that in its child class. Now let's go to wooden platform BP first and here give its respective mesh. After this, let's go to concrete platform BP and here give its respective mesh. Now here we haven't created any socket point for this platform meshes, so let's open up this static mesh and from here add the socket point just like we did for other platforms. Name this attach point and place it at the end of the mesh. Now do the same with this platform mesh. And there you can see it works perfectly fine for this another platform. And now we have these 2 platform blueprints ready for a game, and now we want to spawn them into a level. So for that, let's go to your game mode, because here we define all the logics related to the level. And here what we are going to do is, just like we created the variable to store all the obstacle classes, we are going to create one more variable like this, which stores all the platform classes we have in our game. And from the variable type, search for base platform BP and select the class reference. Make sure it's an array. Now let's compile, and since we have these 2 platforms in a game, we are going to add 2 array elements here. One is for the concrete platform and the second one is for the wooden platform. Now to get a random platform each time, what we are going to do is, here you see we have this get random obstacle function that we created in the previous part. So we are just going to duplicate this and I'm gonna name this get random platform. And here I'm gonna do some changes to get random platform. Here replace the obstacle class variable with this platform class variable. Then get a copy out of it and from the return node, remove this parameter. Now here just replug the pins and then drag this to the return node. And here let's name this platform class. There you go. And now we can use this function to get a random platform. Now here we have this spawn obstacle event and this event adds obstacle in our path. So the similar way we are going to spawn our platforms. So duplicate this event and here let's rename this event to spawn platform. And here the only change we need to do is just change this parameter variable type to base platform BP and rename the parameter to platform class. Now in your game mode, the similar way, call the spawn platform event. And here let's give it the random platform that it will spawn and also the random lane. And now if we play, here you'll see it also spawns the platform along with the obstacles. That means it's working. But the problem here is sometimes the obstacle and the platform both are at the same lane, because we are just spawning them in the random lane, and sometimes for both of them that random number can be same. So we are gonna fix that in the next part. Now first of all, I noticed a problem here, like as we start running, the player can already see the starting of the road. So to avoid that issue, we can just simply shift the road a little backward. Yeah, that's it. And now that issue must be resolved. Now let's start working on the advanced spawning system. So first of all, in your content browser, let's create a new folder. Let's name this data structure. Inside this, we are going to keep all the data related classes. So right click and here search for enumeration. There it is, shortly called as enum. And let's name this objects to spawn enum. You will understand in a minute why I kept this name. But for now, let's open this up. And from here, let's add 3 enumerators. Now in these we are gonna keep the names of the objects that we want to spawn, like on the road. So the first object that we want to spawn is its obstacle, and the second object will be platform. Now the third object will be none, since there can be a possibility that there is nothing spawned in the lane. Now let's save it and let's go to your content browser again, then right click and now search for structure. Here it is, and let's name this lane spawn struct. Now this structure will carry the information about at which lane what object to spawn. So here in the variable type, you have to set it to this enum. So here search for object to spawn enum. There it is, and name this variable lane1. Now since we have 3 lanes, so add 2 more variables and name them lane2 and lane3 respectively. Now basically a structure can carry multiple variables even of different data types, and here we have like 3 variables for each lane, where each variable contains the value between these 3, that if the lane should have obstacle, platform or nothing. Now we are going to set the default values to none for each lane, since we are going to change it in our blueprints. Now let's come to your game mode, and here let's add a variable. Let's name this object spawn pattern. And in the variable type, search for lane spawn struct, which we just created, and make sure it's an array. Now here what we want to do is, let's add an array element. Now here we can define spawning pattern by telling it what object to spawn at which lane. Like every lane can have different spawning possibility. Like let's say at this lane it spawns obstacle, at this lane it's platform, and here is nothing. So this pattern we can define here. Like the first lane has the obstacle, second lane has platform, and the third one is empty. So this is one pattern, and then we can add another one, and in this pattern we say we have one obstacle and both the other lanes are empty. Then let's add another one, and it says there's a platform at one lane and both the others are empty. And just like that we can define all the possibilities that we want to reflect onto these lanes while we are playing. Now understand one thing here, that here we say the lane 1 has the obstacle, but that doesn't mean it is only bounded to lane 1. Like later when we'll write the blueprint, there we are going to shuffle between these lanes, so there will be like possibilities under possibilities. Like the object can go on to lane 2 and lane 3 also, so it's going to work like that. Now let's add some more patterns. So let's say there is a pattern that says there is one obstacle and 2 platforms. And there is another pattern that says there is one platform and 2 obstacles. And then let's add one more that says that all the 3 lanes are empty. Alright, so after you're done with defining all the patterns you want, now let's come here in this event where you add the flow. And here you'll see we are spawning the obstacle and platform like so randomly. So let's unplug it from here, and we are going to create a common custom event to spawn both of them. And we are going to name this spawn objects. Now in this event, we are going to spawn both of these but with an advanced spawning system. But first, right after we add a flow, call this spawn object event. There you go. Now first of all, let's add an input parameter in this event, and let's name this random pattern index. Make sure it's an integer. Now to this random value, what we are going to do is, here we have all the patterns that we defined before. We are going to get a random pattern from all of this using the value of that parameter. So get a copy and plug this parameter value here. And for now, just suppose this parameter has the random index number. So it's gonna pick any one of these patterns we have defined from this array. Now let's break this, whatever the pattern we got. And now we can access each of the lane variable. Now what we are going to do here is, let's make an array of them. Here add 2 more pins and plug corresponding lanes. Now as I've told you before, there is no object bound to any lane, because we are going to shuffle between the lanes, and that's exactly what we are going to do here. So from this array, if you search for the shuffle, this node helps you shuffle all the elements inside an array. So it will kind of randomize the objects into different lanes. But if we do it this way, it isn't gonna work, because here we are making the array in the runtime. So just simply promote this to a variable, and let's name this lane objects. And now we are going to shuffle the items from this array, which just contains the same items. Now get this lane object array and then search for each loop, which is going to access each lane one by one, so that we can see which object is inside which lane. And to separate the code depending on what value we get from inside that lane, we are going to use the switch on enum. And if the value comes out to be obstacle, then here we are going to call this spawn obstacle event, which is going to spawn an obstacle. And the similar way, if the value comes out to be platform, then we are going to spawn platform. And if the value is none, then we are just not going to do anything. Now here in the lane, we are getting random lane for each of these events. So let's delete this, and instead we are going to use this array index as the lane number. Since the for loop iterates through each lane, and at whichever index we find this value is going to be our lane number, which is never going to collapse. Now where we are calling this spawn object event, here we need to provide the random pattern index. So basically we need a random number between the index 0 to the last index of this array. So here let's get random integer in range, where the minimum is going to be 0, but for the maximum let's get this array and get its length and subtract it by 1. And that is going to be the maximum number we will be needing in a random integer, because this length gives us the number of elements inside an array, which is 6 here, and if we subtract 1 from this, we get the last index of an array, and that is going to be the maximum range of this random integer, and we are going to pass this as the parameter in this event. And now if we play, you'll see it spawns objects and platform pattern wise, but also random in their lane, and you can always customize these patterns according to your own need. Like if I don't want the possibility of this 3 of these lanes empty, I can just simply delete this pattern from this variable, and then you are good to go. And also one more thing here is, go to your platform meshes, and here make sure that its collision are not too complex. Just instead replace them with a simple cube box, so your play will always run smoothly while you are running on it. Now as of now, our obstacles and platforms are spawning pretty well onto this road path, but here is one issue. Like if we jump at the side on this platform, you can see how our player literally goes inside it, and it don't dies or anything, it just overlaps inside the platform. So we need to fix that. So for that, let's open up your base platform BP. Now since this is a base class for the platforms, it of course doesn't have any mesh or something, because that's inside its child class. But just for the demonstration, let's give it the respective mesh for now. So for the ladder mesh, we have this, and for the platform, we are gonna use this wooden platform. Now if our player side jumps into this platform, we can detect that by placing a collision box here. So let's add a box collision component here, and let's name this death box. Now we need to scale this along with the platform. And to scale this, we are gonna use this box extend value instead of normally scaling it. So like we will have proper measurement of the scale. Now let me scale this a bit in the y-axis. I'm gonna keep its value to 100. Now let's place this near the platform to get the idea of the scale. Now there is one issue, like the length of the platform is not constant. So even if I try to scale this box collision on the x-axis, it's not going to match the length of the platform. But at least I can scale this in the z-axis. So let's do that first. We are not gonna cover the whole height, just leave some space at the top and the bottom. Now to scale this in the x-axis, first we need to place this box at the center of the platform, and once we did that, we can scale it perfectly from there according to the length of the platform. So to place this at the middle of the platform, so for that let's go to your construct script, and here you see this for loop which adds platform one after another. So when this for loop completes, that's when we are going to set the position of our death box. But how we gonna set it to the center? So for that, we are going to add the starting of the platform with the ending of the platform, and then divide it by 2, and that will give us the center point. So let's do that here. So here let's get this last platform at H point, which is the ending location of the platform. And to get the starting of the platform, we can get it from the ladder mesh at H point, which should be somewhere here where a platform starts. And to get that location, get the ladder mesh, and here search for get socket location, and the socket name is at H point. So now we are going to add both of these locations. There you go. And since we added the starting of the platform and the ending of the platform, there is one more thing to notice here, that we have this extra part that has been added. So after that addition, the location value should be somewhere around here. Okay, so now let's break this vector, and here we are going to divide this x-axis by 2. And that is going to give us the center location of the platform. Okay, so now let's set the death box to that location. So get the death box and search for set world location. We are going to do that after the loop completes. Now right click on the parameter and split the structure and plug this divided value to the x-axis, and meanwhile we want to keep the y and z at the same value. So get the world location of the death box, right click and split the structure and plug y to y and z to z, and it just copy the same value the death box already have, and it only changes the location of the x-axis. And now if you go to the viewport, here you will see the death box is at the center of the platform, and even if the platform length changes, it always calculates the center of the platform and set its location there. And now we can scale it on the x-axis according to the length of the platform. So to scale this, what we are going to do is, we are going to subtract the end location of the platform with its start location, and that will give us the distance between these 2 points, means the length of the platform, and we can use that value to scale this box. So get these 2 values again, and here we are going to subtract this end point with this starting point. So subtract them, and then let's break this vector since we only need the x-axis. Then get the depth box. Now we are going to scale this box using this box extend value. And to do that in the blueprint, from the depth box search for the set box extend. There it is. And let's split the structure and connect this vector x value to set the box extend. Meanwhile, to keep the y and z value same, get the box extend of the depth box. Right click and split the structure, and from here connect y with y and z with z. And we are setting the x value at the center of the platform. And now just connect the execution pin and let's go to viewport. And here you will see the box is a lot bigger than the platform, and that's because both the half sides of this box are equal to length of the platform. So we need to divide it by 2 and then it will scale perfectly according to the length of the platform. So here just divide the x value by 2 and plug it here, and there you go. And now you can see the depth box size is perfectly aligned with the length of the platform. So once we are done with the scaling, now we can detect if a player has side jump on this platform. But before that, select your depth box and in the details panel, search for the hit event and select the generate hit events option. Because for this depth box, we are going to use on hit event instead of on begin overlap. Because through the hit event, we can get more idea of from where the player has hit the platform. Now first of all, what we are going to do is, when anything hits this collision box, first we want to ensure that it is a player character. Okay, so now we need to know like from which direction a player has hit this platform. Either from this direction or this, because the hitting direction should always be opposite. Because let's say if your character is running on the platform and it rolls and moves side and it somehow touches this collision box, your character might die. So to avoid this condition, we should know the direction of hit. So here let's break this hit structure, and from this you will get all the details about that hit event like location, time, distance and all that. But here we want this normal vector because this normal vector is perpendicular to the face and gives the direction of the surface where we hit. So let's break the vector, and here the perpendicular vector is y here, as you can see here. So it's going to give us the hit value in the y axis. So just for testing, let's print this value. Now before we play, select your depth box and set this collision preset to custom, and here block the pawn, which is our character, otherwise the hit event won't work. Okay, so if we hit the platform from the right direction, we get the negative values, and if we hit from the left direction, we get the positive value, and that's what makes the difference here, the negative and positive value. So let's remove this print string, and here we are going to round this y-axis value, so that we will straight get either -1 or +1. And from this search for switch on end and set the start index to -1, so that when we add the pin, it starts from the -1 and we need it till the +1. And now here, since we know if the value is negative, that means we jumped from the right side, and if it is positive, that means we jumped from the left side. But here, how we are going to ensure that the player has jumped from the opposite side, not the same side. So for that, we can check that the player is playing which animation while he hit the platform, and it could be any of these side jump animation. So to check the condition, here let's get a branch. So here, if the player has hit the platform from the right side, then he must be playing this side animation. And if he has hit from the left side, then he must be playing this one. Now to get what animation a player is currently playing, we can get it from this player character reference. Just search for get current montage, and then we can compare it with the respective side jump animation. So in this case, the player must be playing this side jump animation. So select it here, make sure you have selected it, and plug this to the condition. So if it is true, that means we have actually hit the platform from the opposite direction. So we can call death event after this. Plug it to the true condition, and since this is the interface, we can just give it this character reference because we have defined this event in the character blueprint. Now what if the value was 1? So in this case, the animation montage that we must be playing should be this one. So select it here, and if that is true, the character is going to die. And if you were moving in the same direction, the condition would go on the false. So now let's play and test this. So here let's hit the platform, And we have a weird glitch here. Here our character has died, but for some reason our camera was clipped. So to fix that, here select your platform mesh and in the details panel scroll down and here change the collision preset to custom, and all you need to change is set the camera to ignore and do the same with the ladder mesh. So now your player's camera won't be blocked by these meshes. Now we did those for the meshes that we added manually, but what about those we added at the runtime? So for that, go to construct script and come to this part where we are adding these platforms, and right after we add the platform, here we are going to change the collision for the platform that we add. So from the return value, search for set collision response to channel. There it is. And here we want to change collision for camera and set it to ignore. And that's it. Now the camera clipping issue must be resolved. Alright, so now let's try to hit the platform from the side jump. And there you can see our character dies and there is no camera clipping problem. But there is one more issue here. Like if I side jump and quickly roll, here you'll see we again get the same problem. And that is because the condition was for the side jump, not the roll animation. So a simple solution for this would be to also check if either we are rolling. So let's get an OR operator here. So if any of the condition is true, then our character is gonna die. Now here check if you are currently playing the rolling animation. So from here select the rolling animation and plug this condition into the OR operator. Now we're gonna add the same condition down here. There you go, and now it must fix the issue. Now here one more thing we are gonna do, that as a player hit the platform, we are going to force it in opposite direction. So to do that, here from the character reference, we can get the mesh, and to this mesh we can add impulse. Now since we want to add the impulse in a specific direction, so make vector to get all the axes separately. And here we wanna add impulse in the y-axis, and we are going to get the value from right here from this round normal value. So let's multiply and let's give it any big number and make sure it's a negative, so the impulse will be in opposite direction. And there you go. Now let's play and test this. So here I try to side jump and roll and our player still dies. So it's working great. Alright, so now what you want to do is, to show you that, let me go to our floor BP, and here just for the demonstration, let me add a child actor. And here let me set this child actor as a wooden platform. Now by default this platform location will be at the spawn point, and since the length of the platform is random, it can even go outside the road mesh. Although it doesn't matter since we add new road just next to it, but still what we want here is, we want to stick the end location of this platform to the endpoint of the road mesh. Somewhat like this. And the only location change must be reflected at the front of the platform. So let's try to write such a code in a construct script. Later we will move that code to the event graph, but just so we can see that in the editor, for now we are going to do that in the construct script. So what we are going to do is, we are going to subtract this attach point with the end location of this platform, and that will give us the distance of this gap. And once we get the distance, we are going to add that distance in the platform location, and that is just going to fill that gap from the behind. And that's how the end point will always stick to the end location of the road. But to do that, we must have the end location of this platform, right? So that we can manage it with the attach point and get the distance of the gap. So to get the end point of the platform, get the child actor, and inside that get its child actor, which is our platform, and then we need to cast it to a base platform BP. And once we cast it, then we can access this last platform attach point, which is the end location of the platform. But there is a way we can avoid this casting and access this value. So for that, let's go to your platform BP, and here let's add an arrow component. Let's name this attach point, and we want this attach point at the last point of the platform. So for that, here after you set this last platform attach point variable, so after this, get your arrow component and set its world location, and its location is going to be this variable. So get this variable and plug it here. And now you'll see this arrow component is always at the last point of this platform. So now what we can do is, in your floor BP, we can access that arrow component. Just here get component by class, and the component we want to access is the arrow component. And now it will find any arrow component in this blueprint, which is this. And as we get this, we want to get its world location. Just like that. And here what we want to do is, we are going to subtract this attach point with the platform endpoint, and we will get this gap distance. So here get the attach point and get its world location. and then split this structure, same for this one, and we are going to subtract the x-axis here with the platform's endpoint. X-axis because there the gap distance is in x-axis, like here you can see it. So subtract it with the platform's endpoint, there you go, and with this we'll get this gap distance which we are going to add at the front here. So it will fill the gap from behind. So let's add this distance and we are going to add it with, like, from this child actor, get its world location, which is basically our platform's world location, and add its x-axis with that gap distance, and then set the world location for the platform. Here let's split the structure, and for x plug it here to this whole calculated value, and the x and y is going to remain same. Now just connect the execution pin with the construct script and let's see how it works. Now as you can see, both the platform and road ends at the same point, and like no matter what the size of the platform is, it's still going to stick to the end of the road. Now since we know this code works, now we can move this to our event graph, and we are going to paste it here where we spawn the platform. Just like that. And here we are going to replace this child actor with this child actor that we add at the runtime. There it is. And now let's delete this child actor from this flow BP since it was just for the demonstration. Now let's play and test this. Now here I can already see the difference since platforms are always not at the same place. Like sometimes they are forward or backward because of the length of the platform. Alright, now it's time to set up inputs in a proper way. So let's open up your character blueprint, and here you can see like we are using these key events to take the inputs from the player, and that's not any proper way to do that. Instead we are going to use this input action. So you can search for IA_move, which is this input action event, and this input action already comes set up with the third person template. Like if you go into your inputs folder, here you will find this. It is the event that we are using here, and all the keys binded to this input action are all set up in this input mapping context. Like here you can see all the keys, WASD, up, down and all that. So all these keys are responsible for triggering this event. And to differentiate between inputs, we have this action values. Like here if I press the D key, this X value is going to be positive, whereas if I press the S key, the X value is going to be negative. And the similar way for the vertical wise, we have this Y action value. So this way we can differentiate the direction we want our character to move to. Now just to show you how this value works, let me print this action value. Let's print the X value first. So if I press A, the value is negative. If I press D, the value is positive. Now the similar way, print the Y value. If I press W, the value is positive. If I go down, the value is negative. So now you know how it works. So hold S and click to get the sequence. And we get this because we want to check two conditions at the same time. So get a branch. The first condition is if this X value is not equals to 0. It's just like a filter so that we'll only get the value that are either -1 or +1. Now from this X action value, we want to convert it to integer. So for that, search for truncate. Well, it just kind of rounds the value towards 0. So after the filter, we'll straight get either -1 or +1. So search for switch on int, and we're gonna start it from -1 and add the pins 2 times. So depending on the value we get, the respective pin will fire. Alright, if the X action value is -1, that means we want to move left, and if it's +1, then we want to move right. So here what we are going to do is delete these key events and let's replace them with the custom event. Let's name this one move left, and the similar way delete the D key and create a custom event and name this move right. And here we are going to call the respective events. Move left on -1 and move right on +1. Now let's copy this and paste it down here since we want to check the Y action value at the same time. Now we need to do the pretty much same thing for the Y value. So delete this S key and replace this with the custom event. Call this move down. And same for the W key. And name this move up. And call the respective events here on the respective values. And now we are done setting up the inputs. So let's play and test this. And here our inputs are working completely fine. So now we are gonna work on the currency system. So for that we must have a coin 3D model that we can use in a game. So for that, let's go to your fab. And here let's search for the coin. Let's use this one, since this looks pretty nice, and from here select the format FBX and let's download only. So after the download completes, you can go to the files, and in the source you will find this fbx file, which is a coin. So we are going to import that into our project. So here in our project, inside this asset folder, let's create a new folder and name it coin, and this is where we're gonna keep it. Just import, and there you can see we have a coin. Now let's just quickly go to its material, and here we want to add some glow to this material. So for that, for this yellow color, let's multiply it and plug this into emissive color. Now here you can multiply it with higher value depending on how much glow you want, but I think it's okay with 1. So the coin is a little more brighter. Okay, so now let's go to your blueprint folder, and here let's create a new folder and let's name this currency. And inside this, let's create a blueprint class of vector type, and let's name this base currency BP. And this is going to be a base blueprint for all the type of currencies in a game. Open this up, and here let's add a static mesh component. And let's name this currency mesh. So this will be your currency mesh for this blueprint, like this one which we just imported. And here let's add one more component, that is sphere collision. And this will detect if the player has overlapped with this coin. So if we did, we are going to collect it. So you can scale it a bit according to your mesh size. And now to rotate these currencies, like on the z-axis, we can either write the code manually in the event graph, but we don't need to do that since Unreal Engine already has a component that helps us do that, and that is rotating moment component. Now here, since we want to rotate it in the z-axis, so here in the rotating moment component, we can define the rotation rate. Like this is the speed of rotation on the z-axis. So let's keep it 120. So now it's gonna rotate in the z-axis continuously. Okay, so now let's right click on this collision and add an event begin overlap. So when anything overlaps with this collision box, this event triggers. Now first we wanna check if that overlapped actor is a player character, because only then we are going to collect the coin. Now once we are sure that, then we are going to collect the coin. Now for that, what we are going to do is, in your blueprint interface, open up this game mode blueprint interface, and here let's add a function and name this add currency. And here let's add an input parameter. Let's name this value and make sure it's an integer. Now this blueprint interface we are using in our game mode. So let's go to your game mode. And here if you search for that event, here you can see we got it. And here we can define the logic about adding the currency. But more on that later on. First we are going to call this interface when we overlap with a coin. So here search for the add currency. Here you go. And the main advantage of using blueprint interfaces, we don't need a hard reference. So just get game mode and plug this into the target. Now we are going to give it the value that we are going to add every time we collect a new coin. So let's right click and promote this to variable, and let's name this currency value. Let's compile, and here let's give it the default value of 1. Now after we collect the coin, we are going to destroy the coin itself. So here search for destroy actor. Keep the target to self, and that's it. And now we are going to make child blueprint of this base currency blueprint. So just right click and create a child blueprint, and you can call this coin BP. So just make sure in your base class we don't need to set the steering mesh here. So just remove it, and instead we are going to set the mesh in its child blueprint. And you can make like different kinds of currencies with this base class, like a gem or something like that. But here we just need the coin for this game. So let's open this up, and here we are going to set this coin mesh. There you go. And now each time we collect this coin, we are gonna add up like 1 coin each time. You can even add 10 or 100, just how much you want, but I'm just gonna set the currency value to 1. And now we just need to spawn this coin on the road track. So for that, let's go to your flow BP. And here we are going to add those coins as a child actor. So for that, here let's create a custom event, and let's name this spawn coin. Now here we are going to add input parameters for this event. So let's name this one length. Make sure it's an integer. Now add another one and call this lane number. It should also be integer. Now this length gonna tell that how many numbers of coins we are going to add in a road track, like in a continuous manner. And the lane number, you know, that we've been using for spawning other things, like 0 for first lane, 1 for second, and 2 for the third. But first we are going to call this event in a game mode here when we add a new flow, and just after we spawn the object, then we're gonna spawn it. So get the flow BP reference, and from that we are going to call that event. So here we need to give the parameters value. So for the length, what we are going to do is get random integer in range, where the minimum value will be like 5 coins and maximum will be 10 coins. and between these number are going to be the length of coins we are gonna spawn. Now for the lane number, it's just going to be a random number between 0 to 2. So we are done with calling the event. Now let's actually define the logic of spawning the coins. Now first of all, for the lane number, get a select node and add one more pin since we have 3 lanes, and for each option get the spawn points. Now if you remember, these spawn points are just the arrow components placed at center of the each lane, and we just use them to get the location of the lane, that's all. So here from the return value, get their relative location, like based on which spawn point it picks. Now let's add a for loop here, which is going to start from the index 1 until the length of this coin. Like let's say if the length is 5, then this for loop gonna run the code 5 times. So each time this for loop runs, we are going to add coins in a flow. So search for add child actor component, and from this set child actor class. Now the class that we want to add is a coin BP, but since we only have one currency in a game, we are just going to do it like that. But if you have other currencies too, then you can add this parameter in this event. Just like this, let's call this currency class. Here in the game mode, when we call it, you can just, like how we created these function to get a random class, we can make a similar one for getting random currency class too. But since we have only one class, then we don't need this. So here just select the coin BP. Now here we get the random lane location, like any one of these 3. So let's break this vector to get each axis separately. So let's say we get this spawn point location. So we are not gonna start spawning our coin here. In fact, we are going to start it 400 units before this location, and from there we will start spawning in a continuous manner. So here let's subtract 400 units in the x-axis, and here let's get an add operator, because after spawning one coin, we are going to keep increasing distance from the first one. So here from the for loop, we are going to use this index value to keep increasing the distance in a constant manner, since the index value is going to keep increasing until it reaches the last index. So here we are going to multiply it by, let's say, 150, which is going to be the gap between each coin, and we are going to add it here. Now from here, make transform, and then also split the structure of this location, and the x location is going to be this added value, while the y is going to be this spawn point y-axis. And for the z, here we want to keep the coin at a constant height above the surface, and that constant height is going to be, let's say, 50. So there you go. And now before we play test this, here we are going to do one thing, that is, in your base currency BP, select your currency mesh and make sure its collision preset is set to no collision, because the coin mesh itself should not have the collision. So let's play and test this. And now here you can see the coins are getting spawned at the random lane and in a continuous manner, just like it should be. But there is one problem, like there you can see the coins are going through the platforms, like they do not spawn on top of the platforms, they just go through it. So we gotta fix that. So what we are going to do is, after we add the coin, we are going to draw a line trace by channel, and here it needs the start location and the ending location. So I'm just going to split the structure of both of them. Now get the world location of the coin that we add and break the vector. So the starting and the ending location will be the same on the x and y axis. All we're gonna change is the z axis. So what are we going to do is, we are going to start the trace from a height and end it on this flow, so that it can hit the floor and get the location of the surface. So let's start it with a height of 1000 and let's end it on the -1 z axis, so that it would end somewhere below the floor. Now through this return value, we can check if this line trace got hit, and if it did got hit, then from this onHit struct, we can break it and get all the details about the line trace. And the one that we want here is this impact point location. So just break it, and on the z axis, we are going to add some value like 10, so that our coin will spawn 10 units above the floor surface. Now let's recombine all these values into a vector. So just make vector and connect all these values. And this vector is going to be the location of a coin spawn. So just set its world location and plug this vector as a new location. There you go. Now one thing you can do is, to clean this up a little bit, we can move this code into a function. So let's add a function and let's name this getCoinSpawningHeight and paste it here. And here connect this as a parameter. Let's name this coin location. And after all this, when we draw the line trace, let's return a node and plug this vector value as the output parameter. And let's name this spawn location. And now here we can drag it and call this function. Just make sure it's a pure function so you won't have the execution pin, just input and output parameters. Now here just give it the world location of the coin and it's going to return us the final spawn location of the coin. Just plug it here. And here I made a little mistake. Actually, you want to spawn the coin 50 units above the surface. So just keep the value 50 here. And also, when you draw the line trace, uncheck this ignore self option. Otherwise, the line trace won't hit this floor mesh as it will ignore itself. Now let's play and test this. Now as you can see, the coin spawn location are now varied with the height of the surface. So the problem is fixed. Now we need to show the collected coins count through the user widget. So let's go to our main HUD UI and this is where we are showing the cover distance. So let's duplicate this border as we're gonna make this one for coins and let's give it the same position as this one. And to shift that above it, just minus 75 from the position Y and as you can see, it is shifted above this. And let's change the text to coin and to align the value, let's set this text to filled. There you go. Now let's rename this text value to coin value txt and also make sure that this is variable option is checked for this text value so that we can change the text through blueprints. And now here I'm gonna change the color of this text value, like I'm gonna give it a yellowish color like this, looks great. Okay, so now let's go back to our game mode and here we are going to add the logic of adding the coins. So first let's make a variable and let's name this coin. Make sure it's an integer. Now we're gonna store how many coins we collected into this variable. So set it and we are going to add this value parameter into this coin. Means each time we collect a coin, it's going to add into this variable. Now we need to update this text value every time we collect a coin. So for that, get this main HUD UI reference and through that we are going to access that coin value text and we are going to set its text. And the value that we're going to set is which is stored inside this coin variable. And here make sure the minimum digits are 2 so that the minimum value will be 0 0 instead of a single 0. So now let's play and test this and here you can see each time we collect a coin, its value is getting updated into this UI. So we are done with coin collect system. So now to make environment for our game, in your content browser go to this construction volume folder and go to meshes and from here we are gonna select the assets that we are going to use as our environment. Well, you can use your creativity and use any of them or maybe use any other asset pack to make them. I would recommend that but just for the sake of tutorial, I'm gonna stick to this. So here the first asset that I'm gonna use is this water tank. Well, we can use many of them to cover the sideways. So first let's scale this a bit. I'm gonna give it the scaling of 4 at each axis and let's place this at the sideway. And now we are going to place multiple of them throughout the whole way. So let's divide the viewport and switch to top view. So this way it's way easier to align the assets properly. So let's keep duplicating them till the end of the road. And when you are done with the one side, select all of them and duplicate them to the other side. And try to place them symmetrically to the other side. Now when you're done with that, we are going to turn all these into a single asset. So for that, let's select this first water tank first and after that select all of them. Once you selected all of them, go to your tools and from here go to merge tools. And these are all the assets you have selected. So just click on merge actors. Now you have to give the location where you want to save it. So inside the asset folder, I'm going to create a new folder to keep all of our environment assets. And inside that, I'm going to save this. So there I have our first environment asset and you can see it's exactly that, just a single asset. So now let's place this onto our road. So for that, let me copy the location of this asset to place it onto our road. But before that, I'm gonna select all these assets and press H to hide them. Now let's place this on the road. And now we need to edit its pivot at the center so that we can spawn this environment precisely at the runtime. So let's do that, and when you're done, make sure the pivot is at the starting of the road and at the center. And once you are done that, accept it, and now the pivot has been changed permanently. So let's delete this asset and unhide all those assets which we hid before, because now we are going to edit them slightly to give them a complete new look. And the thing that we are going to do is just rotate them 20 degrees like this. And you can do the same on the other side. It's just a bit challenging since the pivot is on the opposite side this time. So after the rotation, you have to place them manually. And after you are sure that they look symmetrical, you can repeat the same procedure which we did for the previous environment asset. That is merging it and editing its pivot at the center. And after you're done, and now we can move on to make another environment asset. So this time I'm gonna choose this tunnel. So let's place this in the level and scale this a bit. I'm gonna give it the scaling of around 5. And to make it a bit longer, to cover up the whole road, let's give it some scale on the y-axis. And it sort of looks like we are going into the cave while we are running on the road. So that's gonna look really good. And after you're done with the placement, just repeat the same process for this as well. That is merging and editing its pivot. So now let's delete this one and move on to the another environment asset. And this time let's go to low polycity folder, and here in the meshes, I'm going to select this little bridge you see here. Like this is also going to look really great. So let's scale this a bit. I'm gonna give it the scaling of 8 on the each axis. And let's lessen its width a bit, like let's give it 7.75 on the y-axis. Yeah, now it looks great. And there's one thing to notice here, with this scale, it can cover up to 3 roads into this single environment asset. So that's what we have to keep in mind when we are gonna write logic for spawning the environments, because this is going to be an exception. So now let's repeat the same procedure with this environment asset too, that is merge it and edit its pivot. And now we are done with setting up our environment assets. You can add as much as you want, but I am okay with these 4. And now let's go to your blueprint folder. And here let's create a new folder for environment where we are gonna keep all the blueprints for our environment assets. So let's right click and create a blueprint class of vector type. And let's name this base environment BP, since it's going to be the base class for all the environment blueprints we are gonna have in our project. Let's open this up. And first thing first, we are going to add stacking mesh for our environment, and let's name this environment mesh. And like in this, stacking mesh component is for our environment assets. Like here we're gonna set these assets in its child blueprint, but since this is a base class, we don't need to do that here. The only thing you need to make sure here is that your collision preset is set to no collision, since we don't want any collisions in our environment assets. Now let's create child blueprints of this base class. And I'm gonna name this environment1 BP. And since we have 4 environment assets, I'm gonna create 4 child blueprint of this base class. And now we need to go into each class to set the respective stacking mesh. So like for this first environment blueprint, I'm gonna set the stacking mesh to this one, and just like that, you have to set the stacking mesh for the 3 blueprints. So once you are done with all of your environment blueprints, now we need to spawn them into the level. And to do that, let's go to our game mode. Now the first thing here we are going to do is, just like these obstacle and platform classes, we are going to create a variable that will store all the environment classes we have in our project. So in the variable type, search for base environment BP and select class reference, and make sure it's an array so you can store multiple classes. So here we have these 4 environment classes, and we are gonna add all of them into this variable. Alright, now we are gonna create a function to get random environment from this array, just like we made for obstacle and platform. So what we are going to do is, let's duplicate this function and let's name this get random environment. And in this function, let's replace this platform class with the environment class array. And here connect this pin as output and delete this platform class output and name this parameter environment class. There you go. And now we can get this function to get random environment each time. And now we need to write spawn environment event just like we did for the obstacle and platforms. So here in the flow BP, let's make some space here. And here let's create a custom event. Let's name this spawn environment and let's add an input parameter. And let's name this parameter environment class. And here search for base environment BP. And select the class reference here. So through this parameter, we are going to receive which environment we are gonna spawn. So first let's call this event in our game mode, and we are gonna call this right here when we add a new flow, just with that. So here after these 2 events, we are gonna spawn our environment. So get the flow BP reference where that event is, and we are going to call it. And the environment that we want to spawn is the random environment. So this is how we're gonna call this event. Now let's actually write the logic for this. So let's copy these 2 nodes from our previous spawning events. And here whatever the environment class we get, we are going to add that environment as a child actor in this flow BP. Now here for the location, like in other spawning events, we need to choose between different spawn points to decide their spawn location, which are basically the different lane locations. But in this case, we are not going to spawn the environments in any specific lane. Like there is going to be a constant location, which is the starting of the road. So to get its relative location, what we can do is, we can add an arrow component and place it just at the starting of the road so that we can retrieve that location from this arrow component. And it is there even if it's not looking, so don't worry about that. Now here, make transform. And to give it the location, get the start point, and from this get its relative location. And plug this to the location attribute. So now the environment will spawn precisely with the road track. So now let's play and test this. So as you can see, the platforms are spawning into a level. But there are also many issues comes with that. Like they are so random that it looks kind of weird. And if you noticed, the very first road didn't have any environment. And the third issue is with this bridge. As I told you, it is going to be an exception because it covers like 3 roads within itself. So it's obviously gonna overlap with other environment. So we need to fix that too. Now in your game mode, where we spawn all of these things, here you can see we have these 3 separate events that we are calling one after another. So first let's call them in a structured way. Like for that, get a sequence and call them after each sequence. It doesn't really change the code, but makes it more manageable. Now here we're gonna make some changes here when we are spawning the environment. So first of all, we are gonna create a variable, name this environment repeat count. Make sure it's an integer and it should not be the array, should be a single variable. And the value inside this variable will decide how many times the current spawned environment will be repeated continuously. And when it turns 0, we are going to spawn a new environment. So that way it won't just change the environment asset so quickly. So first of all, we're gonna check if it is greater than 0. And if it is, we are going to spawn the same environment. I'm gonna change that random environment soon. But before that, if the repeat count is not greater than 0, that means it's equals to 0. So to manage all that thing, let's create a separate custom event. Let's call this setup new environment. And we are going to call this event when this condition is false. And after this sets the new environment, we are going to spawn that environment. Now here, rather than spawning a random environment, remove it. We are going to create a variable. Let's name this current environment. Make sure the variable type is base environment BP class reference and plug it here. Now let's write logic for setting up our environment. Now the primary task of this event is to set this current environment. Now first, we are going to set the current environment to be the random environment. So it's gonna pick any random environment and store it inside this current environment variable. And then we are going to set this environment repeat count variable and let's give it a random integer in range. So our environment can repeat like minimum 1 time to maximum 3 times. You can change it according to your use. So here the next time we try to spawn the environment, it checks its value and if it is greater than 0, we are going to spawn the same environment. Otherwise it's gonna pick random repeat count along with the random environment again. Now since we are using a random environment, there is a chance that the same environment can repeat again. So to fix that, get your environment classes array, inside from which we are picking the random environment. And in this, there are all the environment classes we have in our project. So we are going to remove that one environment from this array, which is currently being spawned. Let's say it picks the first environment as the random environment. So we are going to remove it from the array, so it won't get picked next time. So the environment we're gonna remove is the current environment. Now after we remove it, we are going to store the removed environment into a variable so that we can add it again into this array when we are done spawning the next time. So let's name this variable removed environment and make sure it's a class reference of the base environment BP. Now we are going to set this variable after we remove our environment and that removed environment is our current environment. Now after the first time we call this event, then the next time this removed environment variable is going to have a value inside it. So here convert it to a validate get so that we can ensure if there is a value or not. So if there is not, then of course we're gonna do our regular code. But if the value is valid, then we are going to add that removed environment back into our environment class. So here get the environment class and we are going to add in this array. And the item that we're gonna add is the removed environment. So plug it here and there you go. And after we add, we are going to repeat the same procedure. And now here just make sure we need to decrement this repeat count every time we spawn the same environment. Like here the decrements means just -1 from the value. So we did that so it can count it properly and goes in the false condition when the count is 0. So now let's play and test this and see how it works. So the environment is pretty consistent now and it looks a lot better than before. But here's again this bridge problem where it covers 3 roads within itself, so it overlaps with other environment. So now we need to work on that. So first, when we assign a random environment, we are gonna check if that environment is our bridge environment, which is this one. So here we can get class display name to display the name of the class. We can also print the string to see the value. Like if we play on the top left corner, you can see all the environment classes, those got spawned. But here the problem is, there is not much we can do to identify the specific class. So there's a way that came into my mind is, like we can change its name. Let's give it bridge environment BP. And now we can use the keyword bridge to identify if the environment class is the bridge environment. So for that, from the class name, get the substring and the starting index is going to be 0. And the length is going to be 6 since the word bridge has the 6 letters. Now we are gonna check if the string is exactly equals to the word bridge. So if it is false, then we are gonna run the regular code. But if the environment is bridge, then we are going to set the cooldown for spawning the next 2 environments. So for that, let's create a variable. Let's name this cooldown and make sure it's an integer. And set this variable here when this bridge condition is true. And we are going to set the cooldown of next 2 environment. So give it the number 2, so it's not going to spawn any environment for the next 2 floors. And in this condition, we are going to skip getting random repeat count and execute the further code. Now here, before we do all of this, first of all, we are going to check if it is equals to 0. And only if the cooldown is equals to 0, then we are going to execute the code. Otherwise, we are just going to decrement it and wait until it turns 0. Now let's play and test this. Now there is this weird issue where the bridge gets removed very early. But if I show you like that, there you can see the cooldown effect is working and there is no environment overlapping issue now. So now to fix that issue, come to your flow BP, and here the issue is because of this death box is very close to the road. Like just for example, if I add this bridge mesh here, you can already see why that issue was coming. So we just need to simply shift this destroy box somewhere at the end of the bridge, like this. So when all of this get removed, player won't be able to see that from his camera view. So now let's play and test this. And as you can see, we passed through the whole bridge and it didn't get removed early. So the problem has been fixed. Alright, now let's make a game over UI. So for that, go to content browser. Here in this user widget folder, let's create a user widget. Let's name this game over UI. Open this up, and the first thing we need to do is add a canvas panel on which we are gonna keep all the things, and then let's search for border. Let me scale this a bit. By the way, you can customize the design however you want. I'm just making to show you. And let's set the anchor at the center, so this border remains at the center of the screen regardless of the viewport size. Now I'm gonna give it a bit of dark color with some transparency, like this. And to be able to add multiple elements like this inside this border, we are gonna use overlay for that. So you can place multiple items like this inside this overlay. The first element that we wanna add is a text. And let's set its size to 75 and the text is game over. And let's give it red color. And let's align this text to center. Now let's add a horizontal box inside this border and fill it horizontally and align to center vertically. And inside this horizontal box, we are gonna add text. And the size you will give to your text, the horizontal box will adapt. So let's give it the size of 50. And we are gonna set text to coin. And I'm going to give it the padding of 20 on the left side. So there will be a little space here. Now to show the value, let's add another text into this horizontal box and set the size to fill, align it to the right side and vertically at the center. Let's set the text size to 50. And let's give it the padding of 100 from the right side and let's set its default text to 00. Now let's duplicate this horizontal box one more time, and since this is just above it, let's shift this a little bit above. So for that, in your padding, let's add 100 from the bottom. There you go. Now let's duplicate this one more time, and this time let's add 100 padding from the top. So it is now shifted downwards, and now we have these 3 text. So let's set this text to distance and this last one to high score. Now you can also give these values some colors. Like for the coin, I'm giving it yellowish color. For the distance, let's give it blue. And for the high score, let's give it green. And now it looks pretty good. Alright, so now let's add a vertical box. And let's align it to the bottom. And inside this, we are going to add a button, which is going to be a retry button. So let's rename it to that. Now for this button, I already have an image, which you can easily find on the internet, so I'm gonna use it for a button. So while we have selected the image in the content browser, here in the normal style, you can pick that image. Do the same with hovered and pressed. There you can see the image has been applied. Now let's change the image size to 100 and for the hovered and pressed, we are gonna keep the size to 120 so that when we hover or press this button, the image size will get bigger. Now let's shift this button a little above. For that, let's add a padding of 50 from the bottom. As you can see, the button has been shifted. Now let's add a text just at the bottom beneath this button. And let's name this retry. So now we are done with designing the UI. Now on this button, let's add an on-click event from here. And when we click on the retry button, we are going to execute a console command. And the command is restart level. So it's gonna restart the level when you click on this button. Now one more thing, that for all these value text, make sure this is variable option is ticked so that you can change their value from the blueprint. And let's also rename these text. So now we are also done with renaming them, and now to update their value whenever we want, for that let's create a custom event here. Let's name this set score text. Now here we are gonna give input parameters for each of the values. So let's name first one coins, make sure it's an integer. Let's add another one, give it the name distance, and then add one more and name this high score. So now we have all these parameters to set all these text values. Now to set these text values, get all of your text here. And let's go with the coin text first. So search for set text, and the text that we want to set is the value that we get from this coin parameter. And here set the minimum digit to 2. So the text will be minimum 00 instead of a single 0. Now just like this, we are gonna do for these two. Now let's connect the distance parameter with the distance text and high score parameter with the high score. So this is how we are going to update the text values with a single event. Now let's go to your game mode, and this is where we are going to create that game over UI. So rather than making a custom event, let's do it with blueprint interface, since we already have a blueprint interface for this game mode. So here let's add a function and let's name this game over. Now in your game mode, you can call this game over blueprint interface as an event, and this is where we are going to define all the logics. So here let's search for the create widget, and here we are going to create this game over UI widget. So let's select it here. And then from the return value, let's promote this to variable to store its reference and then add it to the viewport. Now every time this event gets called, it's going to create a game over UI. But to avoid the spam issue, we can here do one thing, that is get the game over UI reference, right click and convert it to validate get. So if this reference is not valid already, only then we are going to create the game over UI. Otherwise, it means it's already there. Now as soon as we create the widget, at the same time we are going to update these text values. And for that we have this function. So get the game over UI reference, and from there call this set score text. And here in the parameters we just need to give it the respective values. The first one is coin, corrected here. The second is distance. And the third is high score, which we are going to save in a save game class. But for now let's just play and test this. Oh, okay, so before that we need to call this function, and we are gonna call this event when a character dies. So go to your character blueprint. And this is where we have this death event. So here let's call this event. And since this is a blueprint interface, it don't needs a hard reference. So now let's play and test this. So here let's collect some coins. And after that we are just gonna die. As you can see, this game over UI has been displayed to a player when he died, and all the text values are also correct. Now there is one issue, that we are not able to see our mouse cursor. So if I try, there you can see the retry button is also working, and we can restart our level and play again. Now to fix that cursor issue, come back to your game mode, and here in this event, get the player controller and set input mode to UI only. And then search for set show mouse cursor and then set this to true. So now you can interact with UI when this game over UI will be displayed. But still there is one more issue. Like once we set the input mode to UI only and then we click on this restart button, it is going to restart our level, but the input mode is still going to be in UI only, and then our inputs won't work. So there is a very simple solution to this. Here in your event begin play, let's add one more pin to the sequence. Here we are going to hide the mouse cursor and then set the input mode back to game only. And this will happen every time we start a new game. Now let's fix the issue where there is no environment for the first floor. So what we can do is, we can manually place the environment into a floor. Like this. And you can also manually place the obstacle if you want. So now if you play, as you can see, there is the environment for the first floor. Now here one thing to notice is that we have this white stroke around this retry logo. So to fix that, here you can set this draw as and select the box here. And do the same with hovered and pressed. And that issue will be solved. Now here for the high score value, we first need to save that value in the memory. So even if you restart your game, that value will be saved in your memory. And for that we use this save game class. So let's create a separate folder for that. Name this save game. And inside this folder, let's create a blueprint class. And here from the all classes, search for save game. Select OK. And let's name this save game BP. Open this up. Now here let's create a variable that we want to save in the memory. And let's name this distance and make sure it's an integer. That's it. Now let's go back to your game mode, and now we have to load this save game when we call this game over event. So for that, let's create a separate custom event and let's name this load save game. Now here search for does save game exist, and here you can give it any slot name. I'm gonna give it slot 1, and now we're gonna check if the save game already exists, like if that data is already stored in the memory. So if it is not, then we are going to create a save game object. From here select your save game BP, which we just created, and through this return value we can promote this to variable. Let's name this save game BP, and the whole point of loading the save game is to be able to access the data inside of the save game through this variable. Now when we check if the save game exists already, and in the case it don't, then we create one. But if it already exists, we don't need to create it. We just need to load the existing one. So here get the load game from slot and give it the same slot name we gave it before, that is slot 1. And now to load this save game into this variable, here you can see we can't connect it directly. For that first we need to cast to a save game class. So let's cast to save game BP, and then you can load the data inside this variable. So that's how we load the save game. Now here, before we even create this game over UI, first we are gonna load the save game. So here let's get the sequence, and that's the second thing we are gonna do. The first thing is to load the save game. So after calling this event, this variable will be valid. So here get the save game BP, right click and convert it to validate get. It's just for the security so that we only execute the code if the variable is valid. Now from this save game BP, we can access this high score distance variable, and we are going to compare it with the distance a player has covered in the current level. Get the high score distance value from the save game. Oh okay, so actually I want to name this as high score, since it's more appropriate for that. Now we are gonna check if the current distance is greater than the high score, right? It's very simple logic. So if the current distance is greater than the high score, then of course we are going to update our high score value. So from the save game, set the high score value, and the high score is going to be the current distance value. So that's how we are gonna set a high score value, which is going to be saved in the memory. And to save it, get the save game BP and search for save game to slot. And here give it the same slot name, that is slot 1. Now here we need to provide that high score value to display it when the game gets over. So get the save game BP, and from inside that get the high score and plug it here. And now it should work fine. So let's play and test this. Alright, so here you can see my high score, which is equals to my distance for now. And the next time I play and die soon, then let's see the high score. There you can see the high score is still there and the distance is less since we died early. And even if you restart your game, the high score will be saved in your memory, so the number will be same until you beat that score. Alright, so now the last thing that we are going to make for this project is going to be the touch control, so that you can swipe up, down, right, left with the finger when you package this project for the mobile. First let's go to your character blueprint, open this up. So this is where we have defined all the inputs for our character, and to define the touch input, let's search for the input touch. Here it is. So this event will be fired whenever a player will either press, release or drag his finger on the mobile screen, and this attribute will give us the location, like on the screen, at which exact point the player has touched the screen. So here we are going to break this vector to get each axis separately. Now here we only want x and y, where the x value is gonna tell us the horizontal location on the screen and the y value is going to tell us the vertical location on the screen. So to only get X and Y, let's make vector 2D and connect X and Y pins. Now when we press on the screen, we are going to store that location. So here on the return value, let's right click and promote this to variable. And we are gonna name this touch start location. And let's plug this on pressed, since it's going to fire only once when the player will just start to touch. Now let's create one more variable. Let's name this touch active and make sure it's a boolean, and we are going to set it when a player press on the screen, means at the starting of the touch, and we are going to set it false when the touch is released. So this boolean will stay true until the player's finger is on the screen. Now there is this moved pin which will keep on firing when the player will keep dragging his finger on the screen. That means we are continuously changing the touch location on the screen. So what we are going to do is, we are going to create one more vector 2D variable and let's name this current touch location. And we are going to set it here whenever the touch is being moved. And plug this value right here. So we'll be keep updating the touch location as the player keeps moving its finger. Now while the player is moving its finger, we are going to check if the touch is active. And if it is, then we are going to check simultaneously for 4 different conditions. Those are for checking if the touch was for swipe up, swipe down, swipe right or swipe left. So for each of them, we have these 4 pins. Now let's get the current touch location and subtract this with the touch start location. So let's say if we start the touch from here and drag it all the way to right at this point. So after subtracting, it's gonna give us the distance between these 2 points. So after we get that, let's break this vector 2D, since for this case we just want the X value, that is for the horizontal distance, and we are going to compare it like if it is greater than a specific value, like what should be the minimum distance the finger should cover in order to swipe right. So for that, I'm gonna create a variable that's gonna store that value. Let's name this swipe threshold. And let's compile and let's give it the value of 10. You can experiment this value on your own, but I'm just gonna give it this value. Now let's get a branch here to see if this value is true or false. So if it is true, so in that case we are going to move right. Now up here you can see I've already defined these input events from our previous tutorial videos. So we are just gonna use these events in order to move our player in the specific direction. So here on this condition, we are gonna move our player to right. And also here let's print a string just for the debugging purpose that says move right. Alright, now the similar way, let's duplicate this subtracted value, and this time we are gonna check if this X value is smaller than a specific value. Like in this case, that swipe threshold must be in negative, so that we can detect if the touch is opposite in the horizontal direction. So for that, we are going to multiply this swipe threshold by -1. So it will just give us the same value just in negative. Plug it here. And if this condition is true, then we are going to move our character to left. And also here let's print a string that says move left. Now let's copy both these conditions, since detecting the swipe up and down is also quite similar to that. And here the only change that we need to do in the condition is to plug this pin at the Y value except of X. So it's just going to give us the same distance just in the Y axis vertically. So in this condition, we are going to move our character down, also print the string. And in the next condition, we are going to move our character up. So we are almost done. Just one more thing we need to do here is every time our character moves, we are going to set the touch active to false, just so we can avoid the spam. Now set it false after every movement. So now we are done with the code part, and one thing we have to do before we test that thing, that is go to your project settings and here search for touch, and here you'll see this use mouse for touch option. Just check this option so that we can use a mouse as the touch on the screen so that we can test our touch inputs. Now one more thing we need to do is go to your game mode, and here on the event begin play, like here you can see as soon as we play the game, it is going to hide a cursor. So make sure to set this boolean to true so that it shows the mouse cursor. And that's it. Now let's play and test this. So here's my mouse. If I swipe up, as you can see our player jumps, swipe left, player goes left, and just like that, it's working on all the directions. And on the top left, just to be sure, you can see it's calling the corresponding events. So yeah, we are also done with the input touch system. And before I could end this video, I can suggest you something like go to your project settings, and here all the way down to Android section, here you'll find this option of orientation. You can set this to the reverse landscape or simply portrait or sensor portrait, like if you want your game to be in the portrait mode instead of landscape, so that your game ratio will be vertical instead of horizontal, just like any other endless runner game. And then you can also package your game to Android from here, and you can watch any Android packaging video, so you'd get better information how to package your game on any mobile device. So that's a whole other topic. And before I sign off, if you really appreciate the efforts I made to build this game and make a whole tutorial series about this, then you can support me on Patreon. There you'll find all the project files I've ever created for these tutorial videos. So like you can use that project file in your game or simply match the mistakes you made. It is just going to support me a lot to keep making these tutorial videos. So do not forget to check that out. The link is in the description. And you can also join my Discord server where you can interact with other developers of this community. All the links are in the description. And if this video helped you out, you can like and subscribe to my YouTube channel. And I wanna thank Patreon members of this month. Thank you so much for your support. It means a lot to me. Alright, so till then, see you. Bye bye.